All right. I think we have a minute. A minute for the last people to come in. Are we live streaming okay? Yeah. All right. I feel if you... Hello. Hello. I'll just keep on ringing it until people stop talking. Until Howard stops talking, I won't stop ringing. No, we don't. All right, welcome back, everybody. Thank you for coming back, actually. I hope you enjoyed the barbecue last night. I think it was great. I'm sorry there was no dessert, but, you know, you got lots of meat, so you had meat for dessert. Sorry for the vegetarians out there. Okay, so I've got two things to say before we start. First of all, somebody asked me for invoices or proof of registration or whatever. If you want something like that, email info@marineboard.eu telling us what you want and we will make it happen. But please don't tell me because I will forget. And I don't remember what you said. So just email me what you want. And if it is actually just a receipt that you've paid, then you should be able to get that from Eventbrite. I'm not in charge of Eventbrite, so I can't help you with that. Jeroen? Yeah.
So when you want a receipt, Eventbrite gives you a summary, but if you want something larger, you can email us at EII and
Okay.
I'll write one for you.
Yeah. Okay. So maybe it should just go to you instead of coming to us.
Well, if Eventbrite does the job for you, you don't have to bug me. I like that. But no, but if you need a complete receipt, let me know.
Yeah.
And I'll write one up for you.
Okay. And then somebody else asked me about some of the training courses. Lots of people have asked. If you wanted to go to one of the paid training courses and you can't register on Eventbrite anymore, then speak to Jeroen or email ecopath40@gmail.com and you can go and he will invoice you later. That's, I think, the bottom line. If you want to come to the other courses, then speak to Angel, but I think those are nearly full. So I don't know. I think we need to, because we'll change the shape of this room and I don't know how much space we have for a U shape, but maybe we have still space. And then other than that, I think we are today, we have one large session. So session 5 on making ecosystem-based management operational and policy relevant. And Kieran is going to be your master of ceremonies.
My PhD supervisor, everyone. Morning again, everyone. So yeah, like Sheila said, this morning's session is going to be on ecosystem-based management and how we're making EWE more operationally relevant in policy. We've got quite a lot of talks that are across the board, the different kind of policy realms. We've got some environmental climate stuff moving into fisheries, then links between fisheries and socioeconomics. And I think we've got some offshore wind stuff too. So starting off this one, I was going to say before we start, we've got some more student talks here, Kim. I don't know where the cutoff is for when you want people to.
More student talks until lunch. Right at the start of lunch will be the deadline for submitting your votes, because I have to take a look at it to figure out who's winning. So think about this in the coffee break, but there will be one more talk after the coffee break. So consider that one as well. And then right when lunch starts, that's really the last moment for everybody to put in their votes. So please do.
Right. Thank you. So up first, I think so we have Marta Cole, adaptive capacity and resilience of European seas under contrasting climate change trajectories and multiple management interventions. I'll say, I'll at 10 minutes, I'll hold up that sign. So okay, you'll know.
That's really stressful.
Is that okay?
Okay. Okay, thank you very much. Can you hear me well? And this goes like, okay, fantastic. So it's a great pleasure to be here today to present the results of a 4-year project that we have been working in a collaborative mode between several institutions that you have here and several people. And the ones that are in blue are around. So please, if you have questions, grab me, but also you can go to these other people. This work was done in the context of Future Matters, which is a project that wanted to understand the potentials of nature-based solutions to protect biodiversity and ecosystem services in the context of climate change. So the idea here was to explore through different work packages and activities how nature-based solutions, which would be restoration and protection and sustainable fishing, would allow us somehow to at least partially mitigate or not the impacts of climate. So in this context, several of us, the modelers of the group, met and started thinking, okay, what we can provide to the project in terms of projections of these species and habitats, and combining these different nature-based solutions, what we would learn if yes or not, would be able to somehow mitigate or adapt to these climate change impacts, and also understand the trade-offs that may be between the different options that we have. So I'm going to walk you, this is the workflow that we followed. It's dense, and I'm going to try to walk you through it. Basically, we had a first part of the project where we had downscale projections of climate that the other colleagues did for us. And they gave us these downscale projections of the different regions where we had our models. So that would be number one. So we then queried those ensembles, especially those downscale projections for our different ecospace models later on. On the other side, we had some global socioeconomic scenarios that were also given to us. And those are scenarios where scenarios, archetype scenarios, how future may unfold and the very different socioeconomic and political conditions. So we had what we call the global sustainability scenario, where everybody is happy and green and follows the environmental rules. And there's a national enterprise where there is more emphasis on the countries winning and getting what they need in their own country perspective. And there is the world markets where here the emphasis is on economics and revenues. So we were given that, and our job was to downscale those scenarios to narratives that were meaningful for our regions. And then when we had downscaled those scenarios, thinking about our nature-based solutions, so protection, restoration, and sustainable fisheries, we needed then to think in individual regions, what would that make sense? For example, in the Mediterranean, where you would place certain MPAs, or where would you restore certain habitats, etc. So each of the 7 models had to go through the process of then downscaling that. And then when we had those exercises, we obviously used our ecospace models that were fitted, some were validated, and they were the best we had in hand. And then we standardized the mechanisms for what we modeled, the climate effects, but also the nature-based solutions, how we model the protection, the restoration, and the sustainable fisheries. And then after that, we obviously obtain a lot of indicators that we tried to standardize. And indicators are in terms of commercial species, of vulnerable species, but also of ecosystem indicators. Unfortunately, I won't be able to show you a lot of results, but I'll show you some results, and the delivery is going to be out there soon. Very quickly, we had these downscale projections. I won't go into the detail because there's a nice publication that explains how these colleagues did the downscaling and how they validated the downscaling with observations. And what we did is to extract for each region this downscale information in terms of the environmental elements that we were going to put in our ecospace model. So here you have for the Western Mediterranean, the time series of the different RCPs, and that as the spatial temporal maps that would go into the spatial temporal framework. Just an example. In terms of the global scenarios, we had these three global scenarios, and they have different dimensions of the future in terms of the political, environmental, societal, technological, legal, and economic. So it was very interesting to sit down between colleagues and with some stakeholders and really ask them, okay, under this condition, what would mean for political targets, for conservation, restoration, etc. So what we did is come up with first this narrative where we say, okay, in a world where global sustainability is a priority, what we would do in terms of MPAs. Well, one option that we took is, okay, we would really try to meet this 2030 protection, the 30 protection in 2030, or we would try to reduce by cuts to the minimum, but this would be contrasting to if we are in a world market scenario where we want to maximize the revenues. Okay, so then we went to our models, and here we had 4 regional models. They were ecospace models, so there's listed there, and then 3 sub-regional models. And in addition, we had for the North Sea, we had a dynamic energy budget model to represent restoration of oysters that were also informing the restoration part in the North Sea ecospace model. We also chose some species that were relevant in each region. In some cases, they overlap, and in some others, they don't. But so we had commercially relevant and relevant species for conservation for each of the regions that we also wanted to look in some detail. And finally, for the restoration, we also target different species according to the context of the region. So for example, in the North Sea, we model how to restore oyster beds, or in the Western Mediterranean, seagrasses and coralligenous species, or in the Baltic, the emphasis was done on decreasing eutrophication. So really increasing the conditions of the water. Okay, and then mechanistically, how we did that, I think that's probably the most interesting for us, is that we put, I think, the ecospace and ecopath to the limits, because in each scenario, we really used ecopath, ecosystem, and ecospace to mechanistically represent the different mechanisms that we wanted to include for the restoration, protection, and fishery sustainability. So for example, we use the spatial temporal framework for the climate. We use the MPA dynamics tool to open and close the MPAs and the fisheries restricted areas that we were placing, or we use the biomass emitter to restore these species. So there's a lot of detail here, but I am happy to discuss later if you are interested. And this is an example in the terms of protection settings. So you understand what kind of information went in, for example, for protection. Here we have, this is the Western Mediterranean. We have the current protection. So this is what has been there in the past. And in terms of fully protected areas, highly protected, and moderately protected areas. And those are the 3 proposals that we implemented in each scenario. So in a global sustainability would be like that for fully and highly protected areas, world markets, and national enterprise. So what we did is, in the historical period, we used a current protection until 2021. In 2021, there were some regions where had already implemented something else in terms of fisheries restricted areas or some other protection. And then in 2030, we implemented the three schemes for protection. Okay, and now I'm going to, I think, how many minutes I have? This is a bit stressful. Okay, 8. I'm going to show you some of the results that we got from this exercise. We got a lot of results, and we have been working hard to try to summarize them in a more or less understandable way. So I'm going to walk you through this figure. Basically, you have here the biomass final over the biomass initial for the key commercial species that were in that big table that I show you, for each of the 7 models that we were running, and for all these scenarios in one line. So we call these like lollipops, and where they show you that you can easily compare. So there you have in green the global sustainability, in the national enterprise in blue, and in red the world markets. And the status quo, I forgot to say that we had the status quo scenarios where we maintain, so we included the management and all that, the management that was implemented historically, and we added climate, but we did not include any additional management that would come into our different scenarios. Okay, so you can compare the differences. And overall, what we see is that there's larger effects as you move in time, especially starting in 2050s. We don't see that much in 2030, but start seeing some important changes in the different models. The status quo on the world market shows declines in some of here, but also some of the other indicators that we looked at. Global sustainability and national enterprise show increases with time, and there's overall a trend where global sustainability shows better results than national enterprise and the world market. In this case, the exception is the Baltic, and you can ask Rika that is around, that will explain you why. In terms of key conservation species, the same concept, okay, the same scenarios, and we see similar results as well. We saw changes in time that get amplified. The status quo shows declines. The global sustainability shows some increases, and then there is of course a lot of heterogeneity, which is also an important result. We don't see that all the regions behave the same way. And this is a last result I want to show you. So this is the same concept for commercial species and conservation species, but within the closed area. So what we call the fully protected areas, right? Only in the fully protected areas to see we were able to rebuild those species. And it's quite interesting. The first noticeable thing is that if you are in the line, it means that you are not different from the status quo. If you are up or below, is that there are some differences from the status quo scenario. And the first thing that we notice is that the effects of management seem to be there compared to the non-management. So non-management in these climate conditions will make a change somehow. The impact is especially noticeable for the local Baltic Sea, which is this one here, okay? For the Western Mediterranean and for the Bay of Biscay for commercial species. So we see a larger reaction in these systems. But for conservation species under the global sustainability, the Mediterranean reacts very strongly. And I guess that's because of the poor condition that some of these species are. Those are the big dots over there. There's larger effects in global sustainability, again, as in comparison to the national enterprise or the world markets. And we see this heterogeneity between regions that we are now trying to figure out. In some cases, the starting conditions of the systems are very different. So that explains quite a lot why some systems are more reactive than others. Let me see, do I have? Okay, last slide. So the take-home message of this work so far is that climate change is projected to continue impacting European seas that we have seen already, and it's nothing new from our project. But I think the interesting part is that we show divergent trajectories between the scenarios that include management with the scenarios that are the climate change and analog that we say that don't include management. And I think this is a hopeful message that this project shows somehow. So proactive management in European regional seas can make a difference. And I think that's very interesting from these results. Nature-based solutions, in this case, protection, restoration, sustainable fisheries, can play a role, at least if you combine them to partially mitigate the impacts of climate. And ecosystem-based management intervention seems to be crucial to really put these systems and somehow in a resilient condition. And with that, I'll finish. There's going to be a deliverable, hopefully somewhere this year. We are also trying to write a paper, but I won't finish without saying that this is really work that we did with a lot of people collaboratively for years, a lot of thoughts and a lot of fun, but also a lot of stress moments as well. And I would like to thank them all. Thank you.
We've got time for a question. Yeah, Dave.
Great talk, Martha. And, really this collaborative effort, is really amazing. I don't know how you guys pull that off year after year. Very impressive. The question I had though was on your biomass responses. It looked like there was one region where the world markets were always higher potentially. Go back to the next slide.
This one?
Right. Yeah, it was the North Sea.
The North Sea, yeah.
Can you explain, or maybe you said this, but I missed it. Can you explain why potentially like the North Sea in like 2050 and 2100, the world markets have a higher biomass. Is there something unique about that system driving that?
Well, there's first the primary production changes are going to be very different in the north and in the south. So and the temperatures as well. So that conditions a lot the trajectories of the systems. And we really see that what's happening in the north and in the south is a bit different. So in the south, we see these declines of primary production, and there's these effects of temperature, while in the north, there is some increases. So that conditions a lot. So the trajectory of the systems is different. The North Sea has gone through a trajectory of recovery, and they are already in that inertia.
Okay.
So without doing much, keeping doing what they are doing, they are already reaching some good solutions, right? So our management adds on top. But it's not like other systems that you really see that the trajectory changes the direction. But Chris Linham is probably the best person to explain all the nitty-gritties of the model.
Thank you.
Okay, thanks.
All right. Up next, we have Xinhua Xu looking at incorporation of ecotrophic dynamic models to conventional single species fishery stock assessments in the Arctic under climate change scenarios.
Good morning, everyone. Good morning, everyone. I'm Xinhua Zhu from the Fishery Solutions Canada Freshwater Institute in Winnipeg, and appreciate the organizing committee to having me here talk about some of the research progress on the article reading. So I'm sorry, just to change a little bit the title from abstract submitted early. So that's it. 10 years ago, I talk about comparison to the Ecopath, Ecothin, on the Lake Erie and the Great Slave River ecosystem. Today, we mainly talk about Arctic reading, Arctic Great Lakes. So that's just showing, sort of quickly say it's the recent publication on the ecosystem for Lake Erie ecosystem. That's talk about study on the hypoxia because of the nutrient in the central Lake Erie. This one, just quickly, I think it's talk about the simulation on the invasive species on the golden mussel, killer shrimp, and roof. And this one talk about the zebra mussels, the guaga mussels that are coming. And the last one talk about invasion of the Asian carps into the Lake Erie for the web. So things that just quickly introduce some application of the ecosystem result. Now I focus on today. I want to talk about more Lake Erie ecosystem. I think we're switching into the Arctic Great Lakes, and I think it's in Canada. In addition to the Hudson Bay, and there are two large Great Lakes. We call the Arctic Great Lakes in northern Canada. So all situated at Northwest Territory. And this one's a Great Bear Lake. This one's a Great Slave Lake. Now talk about the Great Slave Lake. Great Slave Lake is the number 9, the largest lake in the world, with the depth of more than 614 meters deep. So it's it's the typical electrotrophic, and I think it's just use the database over 17 years to reflect some of the changes of the climate, the air temperature, the precipitation, and this one, the water level, and this one, the discharge through the river, because the discharges through the Slave River, this area, is the largest the inflow, and bringing lots of the nutrient system and into the Great Slave Lake. Otherwise, the Great Slave Lake typical oligotrophic. So I don't want to detail more detail, But the main result that they're showing is that as a result of the continuing change of the climate, particularly in the Arctic region, we will say is the warmer in the wintertime and the more rain in the summertime. And I think the more variable the water level because of the, like the slave river also also water regulation through the dam, through like the evaporation, something. And the most important thing is the last one is less discharge in the summer because the summer is the large, the larger proportion of the nutrient and discharge through the discharge on the river into a river system. Now, after that, the 10 years ago, the meeting, we continue working on the Great Lake to conduct the model, integrate the ecosystem study, including the zooplankton. And I think that you can see the zooplankton dominated by canoid and cyclopoid. Things that is changed through depths and still the quite significant into annual variation. And this is the benzoes the similar trends with the zooplankton. So that's lots of the into annual variation. And the most important thing is the Great Lake support the largest commercial fisheries in the Arctic region and dominated by this one, so the whitefish, and this one, the lake trout. So think that, and plus the ink canoe. So three important species to support the commercial fisheries started in middle 1940. So, and the green line is the fishing quota is for the fisheries management. They set up for a total allowable harvest level. In addition to the commercial fisheries in the Arctic region, still the significant portion of the fisheries used by Aboriginal community, we call it subsistence fisheries. So they use the study, and I think back to the middle 1940, I think the population that still who eat the fish increased until the 2000. And then after that, the population seems like it stabilized at that level around the 2100. And I think that annually they consumed about 100 tons of the fish for the subsistence fish used. So that's the thing. I think that in Great Lake, based on the survey, they are a total of the 25 species. So you can see the fisheries ecosystem pretty simple, particularly to the fish composition, only 25 species. And I think that the dominated by the salmonid or the cold water salmonid like lake trout, whitefish, ink canoe, and the cisco. So but they also with the longevity. So like the whitefish that can live as long as 42 ages. And also things, the whitefish, the number one species, but that is the typical bensicivore, and the lake trout and the ink canoe is the placeable. And the cisco is the important pre-species in the system, which are termed like practicable. So this is just we finished like fish stock based on the single species. So this is the fisheries, and we just use the precautionary approach to do things as single species stock assessment. This is the 4 colors divide based on, we call it the precautionary approach to assess the stock status. As the fish is living in the stay in the green area, we call that healthy zone. In the red area is the critical zone, and the orange and the yellow we call the cautious zone. So as to the species for lake whitefish so far, it's still at the beginning and then including the state. So say it's still healthy. And look at the diet matrix for the young of the years, like whitefish dom. Well, the mainly consume a lot of the copper pot. But as that as the fish became the immature and the mature, things that they dominated by the benthos something. So the typical to the benthic species. And this one is similar to for the lake trout, and you can say to the lake trout experience the evident declines around the 1968. Things that is sensitive to the high exploitation. And the diet is made, so the young of a year live on like the mice. And so this one just live on the scorpion and the cisco, and it's a part of the whitefish. So that's the pixel things, because most of the life live on the fish. And this one is a Cisco. Cisco thinks, oh no, it's for in canoe, showing the very dynamic commercial fisheries because the international demand, especially recently. So we assess the stock in canoe stock in the Buffalo River, and they think that right now the population say the critical zone. So think that that's the same signals that so the stock status should be under the strict management action to protect. And this one thinks that in the Slurry River. And this diametric, mainly you can see the adults, mainly consume the fish. Now, roadmap to using the single species, the dynamic information plugged into the ecosystem on the climate change. So think that this is the So think it's divided in 3 categories. Now we are in the single stuff, and we want to move into the ecosystem approach to fisheries management. And in the right side is the therefore this SAR, and published last year. That's the National Advice on Guidance of Developing the Reference Point on the stock status provision. So we bring up this, to the Ecopath model for Great Slave Lake, and showing it's the 2 major, like the traffic connection, and also we want to consider about the number of the factors, the transboundary and the water regulation, think the river and the lake. That's a very phenomenal pattern to influence nutrients in the lake. And we just refer to number of the ecological reference point. Here to the hydroclimate, the climate, the low traffic factors into this group, and also the biological reference point. And the thing is that so the biomass of the PDB into the Ecopath, and I think it's the fishing effort control. The most important is we should consider combined some measure to recover potential assessment, RPA, particularly for the species at the risk, like Cisco, like declined lake trout. So this is just the map, the diagram showing that's about the exercise that we call the assessment and the management framework, and use the Beijing Belief Network. Let's try to track the historical response to fisheries development from early to the current, and the traffic medication faction to the EAFM, the ecosystem approach to. So that seems to the short term and long term. That's it. Thank you. We have time for one quick question. I have a question.
So your work's combining Ecopath with Ecosim, and you're using the single stock assessment models as well. I was wondering if there's any collaboration in this between ecosystem modelers and single species modelers?
Yeah, that's a good question. I think so that we're mainly working for the features management, but not right now we realize the pretty important, pretty evidence, so the evidence things that change climate. So just this talk is just for the proposal, the framework. And I think it's plugged into the number of the faction, how the change like a climate, the air temperature, like kind of particularly like a discharge. So I say the low nutrient input will largely impact like a low traffic level production. That's a thing. Second, we want to combine like the species at the risk. Yeah. Thank you.
Brilliant. Up next, we have Ioannis Karamidas, who is a student looking at integrating spatiotemporal modeling for fisheries management and marine protected areas in the Eastern Mediterranean.
Hello, everyone. I'm Ioannis Karamidas from Aristotle University of Thessaloniki. I'm a PhD candidate there, and I'm really happy to be here in this great conference. It's a privilege. The work I'm going to present is part of the last stage of my PhD, and it's also part of the Horizon 2020 project called Ecoscope. So everything started 3 years ago with the development of the Ecopath model for the Aegean Sea, which was published 2 years ago. And most recently, we proceed with the development of the Ecosea model. And there we explored some fisheries and climate change scenarios. And currently, it has been submitted for publication. This work today, I will present the spatiotemporal framework of this model with the development of the ecospace model and the processes that went through the food web, tried to explore also the potential suggestions of some marine protected areas. The Aegean Sea is located in the eastern part of the Mediterranean Sea, and the modeling area of around 200,000 square kilometers contains parts of both GSA 22 and GSA 23. And the developed Ecopath model was structured with 44 functional groups, with biomass and catch data from an average period between 2003 and 2006. And the fishery sector was incorporated in the model with 4 fleets, including for the first time data from both Greece and Turkey. Next, and regarding the EcoSim simulations, the calibration period was from 2006 to 2021, and the simulation period was run until 2050. The baseline model was incorporated fishing effort and temperature as proxies, and then we developed some fishing effort reduction scenarios in order to explore the consequences of fisheries. We also included climate scenarios from RCP 4.5 and RCP 8.5 to see the effects of climate change, and also some combined scenarios to see the synergistic effects of both fisheries and temperature rise. Here is a graph which is included in the submitted paper regarding the biomass changes of commercially important functional groups in the Aegean Sea for the climate scenarios. And here is a similar graph regarding the catch. I will not focus here, it's just to show that we use the same EcoSim time series and parameterization for the ecospace model. However, I want to mention here that after the submission and following the suggestions of the reviewers, which it's possible to be here in this room, we recalibrated the model with the predator-based vulnerabilities instead of predator-prey ones. And in our case, this worked better, and we got better results in the ecosim. So the study area for the ecospace was constructed to an almost 150 by 150 grid using the bathymetry of the area, resulting in around 25,000 cells. And the surface area of each cell is around 18 square kilometers, which is a relatively big cell area. The challenging part here is that the big study area is accompanied by a big and diverse coastline and many islands. So we have to we conclude that by reducing the grid size and the resolution, it was more feasible for the model to run successfully. And the next step was to insert the available environmental layers and also the dynamic versions of them until 2021, along with the benthic habitats of the area. And then to apply them to all groups as foraging responses. In the left is an example diagram of SST preferences for the functional groups of the model. And on the right is the way that we inserted them in the model in a Gaussian-shaped distribution for each environmental layer and for each functional group. Finally, we incorporated the spatial fisheries restrictions in the Aegean Sea for each fleet as they are formed by the Greek and Turkish legislation right now. Here is, for example, is the permanent and seasonal restrictions for the bottom trawlers on the left and the purseaners on the right. And then we made our model run. This parameterization led to the results. And this graph shows the biomass simulation of all functional groups in 2021, which is the last year with observed data. And here are the results from for 2050, which is the last year of the simulation of the model. And we observed some biomass gains especially in the deep sea fish, the mackerels, and the European anchovy. And on the other hand, we observed some biomass losses in the red mullets and in the European hake, which both of them are very important species for the commercial fisheries in both countries. And also regarding spatial distribution, we also observed some patterns. And we see that higher concentrations were in the northern part, which is considered to be also more productive because of the Black Sea inflow and the large rivers in the area. And we see, for example, in marine mammals, the dolphins and the monk seal, higher concentrations were in the northern part for both species. On the other hand, this is the graph for the cats. It declined in all cases in most groups, except for mackerels and European anchovy, which had an increase. And this decline was higher after 2021 and reaching 2050, which are our forecast period. In this table, we present the ratios of increase and decrease for both biomass and cats in 2021 and 2050 compared to the starting year of the model. And regarding total biomass, we saw that we had a decline in 2021, but then biomass increased by 10% in the end of the forecast period. On the other hand, cats declined both in 2021 and 2050. And now here is a graph which is currently in a preliminary stage, this effort, and we try to illustrate the biomass concentrations in the form of polygons. To see it, actually, yesterday gave a very nice presentation regarding this effort. Here is a snapshot from a time interval in 2021, and the main idea is that if we put each time interval one the top of the other, we can maybe see a pattern regarding the movements of the species in space. Also, we can have a look in some distinct patterns. For example, here is a group of medium-large fish, demersal fish species, and we see that two distinct groupings have been made. with a bigger one being in the north. Here, for example, lobsters have smaller groups together, and there are some species that they're in the whole area. Planktonic groups most probably will be like that. So this can help us make better suggestions and to see which areas are better for a proposal for marine protected areas regarding what we want to examine about each species. And also we can see some patterns and have some patterns regarding their movement and the coupling of some functional groups that they move together, maybe some predator and prey, to see if they move together or they move in opposite directions. And this brings us to the next steps, which is the exploration of possible ecospace scenarios with spatial fisheries restrictions. It's the action plan from the European Commission is suggesting that by 2030, 30% of the marine areas should be protected and 10% of the total area should be a no-fishing zone. And right now in the Aegean, we are standing at about 2% to be protected, so work needs to be done towards this. This will help us to understand better and see the ecological and socioeconomic consequences of that, and also to see the potential biomass gains and the replenishment of the stocks, to see the fisheries and catch redistribution, special redistributions, and also with implementing some ecological analysis and ecological indicators, we can support better these results for management and policy purposes. And finally, usually research effort usually try to follow politics, and most of the times an action has also a reaction. Right now, Greece and Turkey have both proposed the areas in the Aegean to be selected as marine protected areas and marine parks. In the case of Turkey, these areas also included international waters. So we want to also incorporate this suggestion and these decisions to the model and see how the model responds and see what is the take home of these results. And hopefully the relations remain like this. And yeah, this is it. Thank you.
Have any questions?
Thank you very much. I really enjoyed your presentation. One of the very ecologically very obvious effect of the temperature change is respiration. How did you, in detail, how did you like implement in your model respiration change?
You mean respiration regarding the oxygen, the dissolved bottom oxygens we use?
Yeah. What was your method for it?
I mean, it was the same for all environmental layers. We decided to incorporate them, all of them, in normal safe distributions for each functional group. And the good thing that it was that we also have the data to actually each layer to have monthly steps in order to replicate this base map in time. So this helped, I believe, the model to be more close to reality, and also these environmental parameters were more evident. Also regarding primary production, because we actually see the results that in the northern part we have much higher concentration because the northern Aegean is way more productive. It has the Black Sea inflow, and the southern part is the opposite. Also, temperature there made issues because it's the southern part is usually it's hotter than the northern part. So yeah, we did that in all the groups the same.
Thank you very much.
Thank you very much.
Okay, thank you.
Next up, we have Kim, who's going to be talking about co-produced models to evaluate nutrient and hypoxia reduction effects on fishery species.
Good morning, everybody. Are you? All right. Well, you'll see all my co-authors here that I first off want to thank before I forget. This too was work of several people. Go ahead. Oh, wait, am I doing it? So what you see here is the United States and really the Mississippi River watershed. And every year a large hypoxic zone forms right here in the northern Gulf of Mexico, mainly due to these nutrients that come into the water in this huge watershed and out the Mississippi River into the northern Gulf of Mexico right here. So we're well aware that this is happening. So the formation of this zone has been well documented, but the effect on fish and fisheries less so. Also, we have looked into this already, the effect of hypoxia on these fish species of interest and when it's not there. But really in a bit of a crude way, what if there's no nutrient outflow and no formation of hypoxia and compared with it being there? So really the intent of this study is to do it in a more nuanced way, really more plausible scenarios of nutrient reduction and how that affects the hypoxic zone and then the fish and fisheries. So the fish species that you see here is just a small selection of important ones, either commercially. The Penaeid shrimp, the Gulf menhaden are the biggest fisheries by weight and by dollars. A very important recreational fishery is red snapper in this area. Atlantic croaker is the most abundant fish really there, so it represents the ecological important species. So as you saw from the title, this is a co-produced model. It was a project in which we included federal and state agencies. So you see a long list here. I don't think you know any of them really. Some of you do from the United States. So this is just to indicate there were a lot of relevant state and federal agencies that had representatives on an advisory board that really incorporated their thoughts into this project through workshops and a survey that we had during this project. So we've had 3 workshops to kind of get one at the start, in the middle, and towards the end. And we've also this was the work of a PhD student of mine, send out a survey. So I don't expect you to read it. It's just so that you know that there was a survey out to the same advisory panel and with questions that kind of helped us make our work relevant. So I'll start with information learned. You see us, thinking and working on, on what we're getting out of these workshops. So from the start, it was what species to include in the model. It's quite a large model. So we have 60 groups in there, and there was input in there, like what would you really like to see in this model? Also, what scenarios to run with this model? What would be relevant for these agencies? What type of output metric and data visualization is useful? Also, what we learned from them is that uncertainty analysis is necessary. They're not going to accept anything we provide really without it. Part of the workshops, especially in the end, was training. Like, here we have all these models, come learn how to do this. And we've learned from that they wanted a decision support tool and not know how to do this modeling. So a PhD student actually who's here, Michelle Schaefer from Christy Lewis, really focused on that decision support tool. And then what species to include in the decision support tool. We quickly learned that it's soon much too large. You have so much output. So which species exactly, which years, months, it was a very small selection from what was available. So that helped again to see what was useful to them. All right, so as far as the scenario, so this is focused on reducing the hypoxia. A lot of the representatives on this panel were also representative on the hypoxia task force, which is a big group made up of state and federal agencies. And they have goals of reducing the hypoxic area to 5,000 kilometers square. So first had to be determined, you know, what does that mean in nutrient reduction? And then that was by 2035. I can tell you that years shift, so that's not necessarily the year anymore. And then the interim targets to reduce it by 20%. So it's kind of two different things. One is a percentage of production. The other one is kind of a size measure of the hypoxic zone. So we went with these as scenarios. What are the effects on living resources of reductions in nutrient loading by 20% and by whatever amount is needed to reach that goal of reducing the hypoxic zone to 5,000 kilometers square. And you can see from here that that's not necessarily what's currently happening in this area. So stuff needs to happen. And this is a coupled modeling approach. And the I guess here, the lower trophic model is really the term used. So it's a hydrodynamic model with a biogeochemical module in it. Showed that this can be achieved by reducing nitrogen and phosphorus between 40 and 50%. So we used both those scenarios. So the 20%, the 40%, and the 50% to do our analyses. All right, so model development on my end was creating the Ecopath model. We had 66 groups that included multi-stanza groups. Some of it from surveys. We have a lot of surveys in the area, a lot of information from that. Some of it from stock assessment. So any species that had stock assessment, we used the same age classes in the multi-stanza, and we used information from that. We used EcoSim to calibrate the model, and then EcoSpace was really the framework of the model. We ran it in the IBM mode, so the individual-based model mode. And this, to get at that uncertainty, this was kind of a new thing at the end, is to do spatial Monte Carlo runs. The Ecopath model. And so there's fisheries in it as well, and you know, all the species and their lines, and you know the drill. Then, of course, we had environmental responses in there. We had, so the hypoxia, like forcing function, or really and spatially, the maps came from the RAMS model. The response curves I got from survey data, because the trawl data of catch, they would also measure, you know, dissolved oxygen temperature and so on. So we created response curves from that. This is the model area. We had to match, of course, the lower trophic model area. So the orange was to make sure we really only had cells in there that could receive information. This is showing really just 1 year of output from the RAMS model. So you can see the Mississippi River here. There's phytoplankton expressed as chlorophyll right here. You can see time here, so it's spring. As soon as summer comes, there's a lot of phytoplankton growing here. When they sink and die, you see the hypoxia forming at the bottom. So the oxygen is on this legend right here. It becomes quite severe in summer. You see it's July now, August, it really forms. And then it really dissipates again when you go later into the year. So this is September, it's still there. October, it's disappearing. So, so by month, we put this information in the EcoSpace model through the spatial temporal framework. So this is just to show some output, like, do our species actually respond to this hypoxic zone? So here we have white shrimp, for example. It's the little blocks because of the IBM. You see the months going, and indeed, when summer starts, they really clear out of that area and then come back. later in the year. So it's a spatial issue, but also a temporal issue. It's not there all the time, and we see that in the species response. So when we don't reduce the nutrients, again, to kind of show that spatial response and also the temporal response, here we've got those 4 species again that I said I would focus on, that in March, you see some traces of that in the spatial distribution, that something's going on there, but it's very different from August, where they're really kind of clear out of that area, and they have different responses to dissolved oxygen, so it's different for each of the species. So we know something's happening with hypoxia, and then we're looking at the nutrient reduction scenarios. So here it's August, because that was when we really saw that strong response, right? So here, if you go on the rows per species, you can see, well, how do they respond then to the nutrient reduction scenarios? And you do see that it's improving. So here too, it kind of depends per species how strong the effect of it is that they return to that area. But you see there's an effect there. Just real quick, that spatial Monte Carlo, these are probability density plots. It also helped us kind of look at how robust the model was. These look pretty good for the 50% reduction scenarios of what our output that we show is and what kind of the probability of output is in biomass. But interestingly, and I'm using those probability density plots to get these areas of uncertainty around it, and just for a simple picture, what you'd see is just around the baseline what the probability is, and whether those scenarios fall outside of it, because that was really the interest. If we change it, does it significantly fall outside of not changing it? And you see, if we just look at biomass and not a distribution, for the most part, it doesn't, right? So it doesn't change very much. The different colors are the different nutrient reduction scenarios. Black is the baseline. At first, it's just that first run without nutrient reductions, and then we start the nutrient reductions. And the standard deviation just around the baseline. So to look at whether the model was just not responsive, I also separated, nutrient reduction and hypoxia. If we just reduce hypoxia and keep the nutrients the same, you do see improvement, increases in biomass. So it's really that the nutrient reduction and the hypoxia reduction are kind of counteracting each other, so that the biomass doesn't really change very much. But both types of results are interesting to the practitioners. So they may know now, okay, the total biomass might not change very much, but they're interested in the spatial distribution as well. And this is just a quick shot of that decision support tool, so they can look at it, which species kind of clear out, how does it change with the nutrient reduction scenario, what does it do to total biomass, and they can toggle different situations, and they've been trained in how to use this thing. But as a conclusion, really the distribution is more strongly affected by hypoxia than total biomass of most of the fishery species, and really most species in this model. So those positive effects of the hypoxia reductions are counteracted by the negative effects of reduced nutrients. But the spatial shifts are still meaningful to practitioners, so they are interested in these results, and the decision support tool really facilitates the use of that. I know perhaps the question is going to be the uptake of this information, right? I think right now really a bottleneck is getting those nutrient reductions in place. So the hypoxia task force unfortunately doesn't have a lot of teeth, so they can't really make it happen. So the year is shifting. So we know what may happen when it does happen, but making it happen right now is really what's the issue. So I'd like to thank my collaborators. You can check out the tool, a first paper on this. There's another one coming, my funders, and I'll take any questions.
Really nice. Do we have any questions? Yeah.
Thank you. Lovely talk. I was wondering if there is explicit information from the field with respect to whether fish can identify the danger of dead zones and escape, or alternatively stay and die. Do we know something about it?
Yeah, we do. So there's surveys in the area. Also surveys, I guess you don't call it surveys, but information of where shrimp boats, for example, do their fishing. And you can see that they hang out on the edges of the hypoxic zone. So papers that have used data from the field see that there is, a clearing out of that area. Now, it's a combination. So I've used the response curves on the foraging. So we know they can, especially, the bottom feeders, they can't quite reach their food source. So the exact amount of mortality, we don't really know, because it's a combination of movement and biomass reduction, which is what we reflected in the model. So we can replicate the patterns, but really, like, what amount of that is movement and what amount of that is mortality, we don't exactly know. We just know the distribution patterns are replicating.
But roughly most of them escape and less die, or?
Yeah. So, and that's also why I reflected it with the foraging. So, if you're, so I'm doing a lot of work like this now in shallower areas with oyster reefs. There they have no choice, right? So they, when they're stationary, they can move. So definitely for the nekton species, movement is a large part of what happens, and also why you see a recovery in the months when there's no hypoxia and a small effect on total biomass.
All right, thank you.
Hi, can you hear me? So one question is, like, from this region, a lot of like the nutrient loading coming from farming activities. Is there like any involvement from like the land-based stakeholders into the decision to process, or are you guys thinking about it, or is it already undergone?
Yeah, so the hypoxia task force that I mentioned is this group of representative of states and federal agencies, or one federal agency, lots of state agencies. They're all in the watershed. So there's a lot of representation higher up as well on that task force. So they're all involved. There are ideas of best management practices of what to do to get less nutrients in the river. And there's definite work on that. There's not a whole lot of enforcement that they can do to make it happen. So a lot of it is, this is what we should do. So I would say the ideas are there. Really, what would be a nice follow-up study, and I've talked with colleagues about this, is to look at, well, instead of just deciding on a goal, let's, do a 40% reduction. What reduction do you get if we do implement all the best management practices to the best of our abilities? What is that reduction? And then look at those effects, because so far we know, the work is there, the knowledge is there if we need to do all this. What's happening now is not resulting in the reduction scenarios that are set as the goals, for sure. Fine.
Brilliant. Up next, we have Andy Whitehouse giving us a talk on the development, automation, and reception of Ecopath of ecosystem models in ecosystem-based fisheries management processes in Alaska.
Thank you, Jacob. I'm Andy Whitehouse from the University of Washington in Seattle. Karam sends his regrets that he couldn't be here in person to give his talk. So unfortunately, you won't be getting Karam's talk. You'll be getting my interpretation of Karam's slides. But he gave me notes and made me promise to stay on topic. So Anyway, Karim's talk is about sort of the evolution and development of ecosystem models and Ecopath models in particular at NOAA's Alaska Fisheries Science Center, and their eventual uptake into the management process in Alaska. So first, I'm going to start with a little bit of oral history. Back in the late 1970s, early 80s, Levistu and Larkins developed a food web model of the Bering Sea, which they called ProBub. And around that time, that was when the 2 million ton cap in the Eastern Bering Sea, which I mentioned yesterday, that's the limit on total annual groundfish removals in the Bering Sea, that was beginning to gain traction. And that was actually that 2 million ton number actually comes from the sum of the maximum sustainable yield estimates for the 20 managed stocks minus a 15% buffer. But some subsequent analyses with that ProBub food web model was seen as being sort of instrumental in cementing this idea of a total limit on community production in the Bering Sea. And that 2 million ton cap has been in place now for over 40 years. Back in 1982, the Food Habits Lab groundfish monitoring, groundfish food habits monitoring program began, where every year we collect stomachs from groundfishes in Alaska, and that 40 plus year time series of diet data and predator prey interactions has been absolutely just vital in supporting our Ecopath modeling in Alaska. The first Ecopath model of the Bering Sea was actually developed by Andrew Trades back in 1999. And at that time, stellar sea lions had been recently designated as an endangered species. And the model was used to really investigate changes in prey resources and prey switching and what role that might have had in the declines of stellar sea lions. So US federal law requires that there be an environmental impact statement for federally managed fisheries in Alaska. And in that documentation, there are indicator suites that actually include a number of indicators derived from Ecopath outputs, and they've sort of been a formal part of that process ever since. And to this day, there are still a number of Ecopath-related outputs and indicators that are included in our annual ecosystem status reports that are part of our management process. So in 2019, the Regional Fishery Management Council adopted their fishery ecosystem plan for the Bering Sea. And a key part of this is that it was focused on establishing a process for bringing ecosystem-based information into existing fisheries management system. This work was further extended by the Climate Change Task Force of the Council, which described 3 timescales of management and a means of providing information into the process on those timescales. So those timescales on the right are the first one. Oh, and they ultimately call these on-ramps. So the first on-ramp is sort of that tactical near-term advice, and that's information that would inform like the current year's quota setting deliberations. Strategic near-term is sort of a similar time frame, but it's a sort of a bigger picture. It's not necessarily informing like a quota decision. And then strategic long-term, that's more looking further down the road. And Ecopath with Ecosim has provided management advice on all of these timescales. So during the scoping process for that fishery ecosystem plan, in addition to sort of this general recognition that the ecosystem is very complex, there was also recognition that there was a considerable amount of complexity in the council process, particularly in terms of ecosystem-based products that were under development and planned for use or incorporation into the decision-making process. So one of the key feedbacks that we received was to inform but not overwhelm. So while the council and various stakeholders were really keen to hear about species interactions, they really needed the development of consistent explainable outputs and a number of sort of experimental products, such as like fairly complex indicators. They wanted those to be still distilled down to be a little bit more understandable. So Throughout Alaska, over the years, there's been a considerable effort to cover all of the federally managed LMEs, large marine ecosystems there with Ecopath models. So as we heard yesterday, there's an Ecopath model of the southeastern Bering Sea. We have a model for the Chukchi Sea, models for the Aleutian Islands, the western Gulf of Alaska, and the southeastern Gulf of Alaska. And we are currently in the process of developing another model for the northern Bering Sea. Now, for those on-ramps, on that first on-ramp, dealing with sort of that near-term tactical advice, one example of this are indicators that we provide on an annual basis in our ecosystem status reports, which are part of that annual council process. This figure right here is a figure of some foraging guild biomasses that's in our ecosystem report card. Now, those foraging guild biomasses are actually based on an index of our annual bottom trawl survey that we've developed that incorporates an Ecopath-based catchability coefficient. And what this does is that this allows us to include the biomass of a number of really hard to catch species that would otherwise go unaccounted for and not be represented in this process. And this index is not just utilized in these guilds, it's also utilized in a number of other indicators that are included in our ecosystem status reports. And another avenue for this information to get into the stock assessment process is in the stock assessment documents themselves. They have these risk tables in there, and what these risk tables do is they allow the stock assessment authors to say, okay, well, we have this indicator that's telling us this about the ecosystem, and we think it's important for our stock because of these reasons, and they can use that in their rationale for their quota recommendations. And then just as an example, back in about 2004 to 2008, the pollock biomass was fairly low, and along with that, so was the pelagic forager guild. And that trend in the pelagic forager guild was cited as one of the key pieces of evidence, and ultimately would ended up being a reduction in the pollock quota. So another key obstacle that we face in Alaska is time. So our field season ends and we get that data from all of our field work, all of our collections and the survey estimates by the end of September, and we have to have quota recommendations to the council by November. So it's a really rapid turnaround. And this is very challenging, particularly if we want to use an Ecopath model in a tactical fashion. My colleagues, Bridget Ferris and Karam Iden. Bridget is sort of leading an update to our Western Gulf of Alaska model. They are working on developing a workflow to sort of streamline this process where they can connect the model directly to our Oracle database from our trawl survey information, and the same different database with our groundfish food habits information, and another database with the commercial catch information to try and automate that process to more rapidly have that information available so that it can contribute to ecosystem-wide syntheses and really help provide that sort of ecosystem context of the status of resources. For the second on-ramp, this is sort of strategic, but still near term. In this example here, Pacific cod has historically been managed as a single stock through both the Bering Sea and the Aleutian Islands. But in terms of the biomass between the two separate regions, if you look at that top bar graph, the biomass in the Bering Sea actually dwarfs the biomass in the Aleutian Islands. And ultimately what that means is that decisions on quota are really being driven by what's happening with the biomass in the Bering Sea. But however, when we look at it in terms of density, tons per square kilometer in the bottom figure, we can see that in the Aleutian Islands, the cod are a much more important role than they are in the Bering Sea. So Karam and others did a sensitivity analysis using EcoSense. And basically what they did is they said, okay, what happens in these different ecosystems if we remove this huge chunk of cod? What happens to the other groups in the model? And in that top plot, that's showing the change in biomass and the other groups across the food web in response to a decline in cod biomass. And it's a much larger effect in the Aleutian Islands than it was in the Bering Sea. And this, along with a number of other analyses in the stock assessment, were used to ultimately decide to break it into two separate stocks for management purposes. And then for the third on-ramp, this is sort of that strategic, more long-term. You guys heard me blather on about this yesterday, so I won't talk too much about it, but we've been developing climate enhanced projections of the ecosystem to try and help evaluate climate resilient harvest policies. But one of the things that I think, in terms of this talk and in terms of this session, the key thing to note here is that this is information that the council has actually asked for from us. And they've been engaged, the council and the other stakeholders have been engaged in this process from the beginning in terms of sort of telling us what their concerns about climate were, but also helping to decide on what those fishery strategies were going to be that we were ultimately going to use in these projections. And that's it.
Really excited to see do we have time? We have time for one quick question. Sheila.
I'm not sure if it's actually a question to you. The EcoSense thing, is it like mixed trophic impact? It's something different?
Yeah, so it's sort of like it's a Monte Carlo type routine.
Okay.
Where it generates, Sarah talked about this yesterday in her talk, Sarah Weisberg. It generates, you can generate thousands and thousands of or EcoSim parameter sets. And then it rejects those that are sort of unrealistic. And then with those retained ecosystems that you have, then you can just run simulations on all of those to get sort of that distribution of like a perturbation analysis. Yeah.
And so our last talk before the coffee break, we have Lauren Gentry looking at incorporating Ecopath with Ecosim into US South Atlantic fisheries management decisions.
Hey, everybody. There we go. So I'm Lauren Gentry. I'm from Florida in the United States, and I'm a marine ecologist with the Florida Fish and Wildlife Research Institute. And we're like the research branch of the state government's Fish and Wildlife Conservation Commission. And I lead a team of researchers that does EWE modeling for a regional federal fisheries management group. So today, this is not going to be super technical. I really just want to tell you guys kind of a lightweight story about how this partnership began, where it's going, and what we're learning along the way, working so closely hand in hand with management. So our team is myself, everybody's favorite, Dave Shigaris from University of Florida, Luke McEachran from FWRI, who many of you know, he says hi, by the way, and Shanae Allen, who's a stock assessment specialist at FWRI. So this team is funded by the South Atlantic Fishery Management Council, or SAFMC, SAFMC, the council, all of the above, which is one of the 8 regional federal fisheries management councils in the United States. And they manage the recreational and commercial fisheries for the U.S. East Coast South Atlantic, not the actual like South Atlantic, right? Exactly. And they manage 64 different species and their habitats. And while there are so many different important parts of this fishery, one of the bigger ones is the snapper grouper complex fishery. And the snapper grouper complex is 55 species. They're not all snappers and groupers. But what they all have in common is that they are all very important recreationally and commercially. They're all delicious. They're all super fun to catch. And they mostly live on structure or rocky reefs, so they can often be pretty easy to find. Well, in the late 90s, some research staff for SAFMC, they wanted something like a tool to help with their ecosystem-based fisheries management. They had already identified essential fish habitat to protect. They had some fisheries ecosystem plans in place, but they really wanted to explore how different management decisions could affect the whole ecosystem that are so important to these animals. So they partnered with Tom Oakey, the EWE modeler who was at UBC at that time, and a new model was born. And the original model started out with 48 groups, mostly managed species, and it was really built as like a framework to build on in the future years. And as the years went on, the council added more priorities, people added more groups to it. It was used in 2014 to explore forage fish dynamics. And a lot of you in the room were involved in this modeling process over the years. And then nearly 20 years after the model started, the current iteration of the modeling team was officially formed, and we took the model to where it is right now, which is 140 groups, hundreds of data sets, and tons of details that I really don't want to get into today. But it was reviewed by the council's scientific and statistical committee. Yeah, that's right. And it was approved for use to inform management. And one of the management issues that we were dealing with back then and are still dealing with today involves red snapper that Kim mentioned. So these fish are large predators on structure and rocky reefs. They can grow to be quite big and over 20 years old. And they are extremely popular, both commercially and recreationally. I personally know a couple of people who have boats that really just sit in the garage year round, except for the local red snapper season. People love red snapper. But this species was really heavily fished in the 80s and 90s. They kind of plummeted, and they had to enter a rebuilding plan that doesn't end until 2044. But so far, management has actually been super successful at having these fish recover in both abundance and biomass, and a lot faster than expected, especially in these couple of years right here. The problem is that they're all very young. If y'all in the back can't see, all of these oranges and reds, these are all under 5 years old. So they can't really open the fishery yet on baby fish, essentially. But one of the management issues is that folks on the water can't tell that they're young, because a red snapper that's yay big, that could be 3 years old or 20 years old. There's no way to tell. And what this means is that when you're out on the water fishing in federal waters on any kind of structure, you almost can't not catch a red snapper, especially a big red snapper. They will take all of the bait and they prevent you from being able to catch other things. But in federal waters, the private recreational fishery on these fish is only open like 2 or 3 days a year, which means all the other 360 some odd days, you have to just keep throwing them back. It's extremely, understandably frustrating, right? So there's a lot more nuance to the assessments and the management requirements and how people feel about this. But one of the questions that kept coming up at the time from science staff and from fishers alike was, if these fish keep recovering at this rate right here, all the way to 2044, are they going to eat everybody else out of house and home? And that's an ecosystem question, right? So the council came to us and they asked if we could explore sort of the negative impacts of faster red snapper recovery on other managed species, especially the other managed species that aren't doing so well. And so to do that, we created 2 ecosim scenarios using vulnerabilities. And we wanted to mirror 2 projections from the most recent stock assessment. And those projections were sort of this long-term average recruitment that we've seen in the past. And that's sort of a slow but steady recovery. That's kind of what you would normally expect. But then there's this other scenario that's recent high recruitment, and that's what if they just kept going on this meteoric rise because they don't have a lot of fishing pressure on them right now. And what we saw was that higher biomass at the end of the time series really only conferred a negative 4% impact on the black sea bass population, which is the last managed species on that list. And so we stress tested this model just to be sure. I mean, and we got ridiculous. We made black sea bass 25% of the red snapper diet. We increased fishing pressure on black sea bass by 7-fold. We messed with all the vulnerabilities, and we still couldn't really move the needle to see red snapper having a meaningful impact on black sea bass stocks. And this agreed with other work that had been done similarly in the Gulf of Mexico. And it also just kind of made sense that a generalist predator is unlikely to really drive down a prey that's already low availability. This was reviewed by the Scientific and Statistical Committee. It's still used regularly. It comes up regularly in council discussions today. However, we obviously gave the caveat that like this is EcoSim, and so it assumes an even distribution of all of the species involved, right? But you can't really run EcoSpace on this model. Remember what Howard was talking about with right sizing your models? 140 groups is not the right size for this. So that led us to the next generation of SAF-MC models. And that's the South Atlantic reef fish model. So the SARF model is a mice model with mostly the same data as the big original model, but compressed down to just 41 groups, featuring sort of the main focused species of the snapper grouper complex, now with age structure. And one of the best parts of having a smaller model is that you can run EcoSpace on it without crashing any servers. So that's what we've been doing for the last year, not crashing servers, but collecting data for EcoSpace. So we've collected a ton of data to try to build out a very, very detailed EcoSpace model of this area and for this specific section of the ecosystem. And then we also got a lot of data to validate against and kind of explore different ways to characterize this pretty unique fishery in the area. And one of the biggest helps with this has been our really close relationship and eventually like officially including a fishery scientist from SAF-MC staff on our team. He's not just a fishery scientist though, he's actually their deputy director of science, Chip Collier. And he's long been involved in the modeling process. He worked really closely with us, but now he's actually one of us. He's officially one of us now. And so we've got all the modeling experience. He's got 20 years of fishery and management experience in the area and access to projects and data pipelines and people that we might not have otherwise. He keeps us up to date on the changing sort of, current events in the fishery and in the political landscape. He gives us personal introductions to the people who collect and manage the data and the history behind the data so that we can, use it properly and know where it came from. And he also just kind of tells us how managers feel about certain topics. And that has been extremely useful to us. So having somebody from management directly on our team, it not only increases all of SAF-MC's sort of familiarity and comfort with EWE, but it also makes sure that all the work we're doing is easily incorporated into management decisions and policies and whatever needs to get done. Because thanks to him, we know exactly what's being asked of us, whether it's a specific value or whether it's examining trade-offs, characterizing the ecosystem, whatever it is, we know what it is. And he helps make sure that whatever our results are, that they're in the right format and the right language to be immediately incorporated into management. So this mice model is just about ready for calibration that Dave presented on. And one of the things we're going to do with it, its maiden voyage, is going to be trying to figure out what's going on with black sea bass. So you saw earlier that black sea bass had a small negative effect from higher red snapper biomass. And of course, we want to reevaluate this under spatial constraints, but it's unlikely that it's just going to be red snapper because black sea bass have been tanking for about 10 years now, and they're really not responding to management. So one of the things we're going to do is scenario testing to look at the relative impacts of climate change, overfishing, low recruitment, and red snapper. And since we have a number of other stocks that are sort of equally tanking right now, we're also going to be looking to see whether this is specific to red snapper or is this evidence of some sort of like regime shift. And if I've got like 30 seconds left, I also sort of want to throw in some support for wrong-sized models. if you've got one of these giant models, it's probably not the right size for answering certain EWE questions, but it can kind of serve as like a summarized database. We get probably 20 requests a year from SAFMC for non-modeling information, just kind of like, hey, I need a quick list of all the predators and preys for this one species. I get invited to a lot of their workshops, not because of anything to do with modeling, but because I have all of this biological and fisheries information in the model at my fingertips, and it's much faster to look at it there than query some clunky government database for every bit of information that they need to know. And then lastly, identifying data gaps. SAFMC thinks that this is such an important part of the modeling process that they actually write it into our projects. It's a deliverable that we have to identify gaps in the data and then inform management research priorities so that when funding comes available, they already know what they need. So, of course, I want to thank the entire model team, SAFMC, because they fund all of this research, and all of you who made EWE and keep making it better all the time. So, does anyone have any questions? Yes, Howard.
Thank you. I appreciate that about the wrong size models because I agree completely and I've said that a long time. So just to clarify, I was talking about operationalizing for quick answers. So that's all good. The other thing is I'm noticing here is, you know, when you saw that it said up like sea bass, I was like, oh, because they're all going up north, right?
Oh.
But that's an issue we have in the U.S. is we do all this we have all these broken up regions, and it'd be really cool if we had a model that went from North Atlantic to South Atlantic to North Atlantic and could explore questions like this. So maybe that's something we should work on in NOAA.
Yeah.
All right.
Well,
Thanks.
this is also specifically the North Atlantic or the North Florida black sea bass fishery is one of the ones that is also completely tanked. So we're exploring whether the Florida black sea bass, are they moving up to North Carolina, moving out, or just dying? We'll see. Anybody else? Sorry, I know we're trying to get to coffee.
Yeah, well, maybe more comment. I am also from a management and implementation agency. So I really appreciate you talk about modelers talking to the managers, because a lot of times we give funding and we say this is our questions to the modelers, and the modelers think they understand, and we think modelers understand. And after all, we are not understanding the same thing. So so they provide the answer, they provide the answers to us that are not really applicable to any kind of management. So yeah, so more comment. I appreciated everything that's it. Yeah.
Thank you. And we appreciate Chip. We go back to him constantly and say, I know you asked this, but really exactly, because this is really dry and this is really boring. What do we need?
Yeah, that's yeah, well, I will not use more time for coffee break.
I know, right? You got to be friends with them, I think. Yes, legitimately, actually, that was how we got to know him so well. All right, we're done. Thanks.
Yep. Thank you, everyone. I think is that.
Yes.
Yes.
Reminder to vote for the student talks, student presentations, and we now have 25 minutes for coffee. So see you back here at 11:15. And I'm assuming we have all the talks. Yeah. Yeah, it's updated, huh? Yeah.
Yeah.
Just hold on.
Yeah, well, I'm just.
Can you go back to the list of
I was
No. I want to see how you connect. So you're using this to connect to the projector, or how does it work? I'm asking because I
the
have,
arranging stuff. So do you need to put something on?
not now, but I have 75 minutes after lunch.
Oh, you have, do you have done a USB drive?
No, I would like to use my own computer.
Ah, okay.
It's a whole session.
I can ask them, they will know.
It's a whole session. It's this afternoon.
Because we cannot integrate your slides here, would that be possible?
It's a Mac and it has video. So that's two things that is likely, and it's not even PowerPoint.
Okay.
This
We,
somehow connects to
yeah,
video.
yes, it does.
That's probably that one.
Yes, we can, maybe we can try it now.
Yeah, why not?
Yeah.
Yeah.
Ah, yes, Willie, sorry.
Yeah, that's the issue with this.
True. There is a problem, and that's that we're also streaming through
Oh,
Zoom.
the online stream?
Yeah. Angel is the best one to help with this one. So Willie would like to use his own computer for the session of what's next, because it's a Mac and he has a video on it.
One thing that you can do is you can connect to the meeting,
yeah,
and then share your screen.
Okay.
So then the people online, I mean, stop sharing from our side.
Yeah.
But then another time, oh, we can project then your share screen here. So it's a little bit. So instead of like connecting your computer to this system, you just join online, and I think that will be the easiest, maybe.
Okay.
So that people can.
So we
hear.
said this is just after lunch.
Okay.
It's a whole session.
Yeah.
So that means we'll just at the end of 10 minutes before we finish lunch, we'll set it up.
Okay.
Is that the way?
Sounds good.
Okay.
One question, because it's a Mac, do you need other connections?
Maybe we can test.
I
Well,
can get to IT to have some.
It looks like this.
If it's just a USB, then it should be fine.
Well, isn't this HDMI?
No.
It's USB.
Oh, it's USB. Okay.
But then the thing is that he doesn't need to be connected to here.
Because just a
Oh.
stream.
Yeah. Maybe
Maybe we should just test it now.
Then I just need to zoom.
Yeah.
Oh.
No, it's I know. To confirm also yeah, that's one of the unless they decide, you know, in the morning it's like I would I know the problem. I'm glad to work also.
Oh, thank you. Yeah, is that right? Yeah. I like the historic one. Yeah, those are good, like good on laptops, isn't it? Yeah. Just the first one.
You put them somewhere, so.
Yeah, they're gonna go on the doors. Oh, yeah, we could do. Yeah, why not? We could sell them as a sticker sheet.
Yeah. Wink, wink.
Is there a way to make this thing higher easily? Just because I've got to talk later, and it feels really awkward. I'm like this every time. So like this one or something.
Yeah, so you just need to like kind of put it over this.
Can it, does it not hold? Is it too heavy or something?
It's like. Well, they try, but it comes down. So they just like put it here. It doesn't hold.
With that, it should hold. No,
No, it doesn't.
it's rubbish.
Yeah, it's rubbish. So you can just use this as a. Yeah.
Right.
All right. So quickly, I think Kim just wants to talk again about the student trial.
So the voting form has been fixed, so you can complete it. There's one more talk. I've put the deadline at 1:15, but I'm going to give you 15 more minutes so that in lunch, like right when lunch starts, put in your votes. Then at 1:30, I need a little bit of the lunch as well to actually look at the results. If you're in the organization, you have to either log out of your Google Drive. If somehow your Android doesn't allow you to do that, try a different browser. If that doesn't work, grab your student's phone and do it with a different device than your own, and then it should work. All right.
Organization, anybody signing up there were part of the people, you know, in the Ecopath.
Yeah.
Organization.
And specifically, if you have access to the shared drive on Google that we use to organize this meeting. So if you're in there, you can mess up the forum. All right, thank you.
Welcome back, everyone. We're starting off with Sergio Niara talking about approaching ecosystem reference points for small pelagic fisheries in Chile.
Okay, good morning. I would like to thanks first of all the organizers of this conference and also the organizers of this special session for allowing me to present some results of a study we conducted in Chile. Sorry. I would like to also acknowledge my co-authors and the institutions that allow me to visit and stay here in Austin. So in Chile, since 2013, we have a new fisheries and aquaculture law. And as you said in one of the articles, they said that the objective of this law is to point to conservation and sustainable use of resources, right? Applying the precautionary and the ecosystem approach in order to safeguard the marine ecosystem that sustain them. Unfortunately, the management objective is still a single species and based on maximum sustainable yield. Who knows about maximum sustainable yield? Okay. Who likes maximum sustainable yield? Okay. So I don't have to go too much into details here, but as you know that in some point about 40% of the unexploited biomass, you get the maximum productivity and then yield. And once you get this objective right, then you can find the fishing mortality that will lead you to the objective. So you have reference points in fishing and also in biomass. But obviously, this seems to be a little bit aggressive to forage species, for example, small pelagics, because we know that they play a important ecological role because they channel most of the productivity from lower trophic levels, from plankton up to upper trophic levels, where we have top predators and also other fish that might sustain fisheries. So overexploiting or collapsing these forage species, small pelagics, might have profound impacts at the ecosystem level. So some colleagues, you might remember this paper by Smith and colleagues. They ran a series of simulations using different modeling platforms, including Ecopath with Ecosim. So they explore how the catch from different species will change when you start to exploit the population. So in the lower axis is the level of depletion from carrying capacity. And as you expect at the ecosystem level, you get also maximum sustainable catches around depletion of 60%. But also you have big or higher impacts in other ecosystem, other ecosystem components. So they propose that we should move to a more conservative levels of depletion, probably leaving at sea 75% of the unexploited biomass instead of 40% of unexploited biomass. So for a country as Chile, which is probably in the top 10, I think we now are in the 12th position, but a few years we are still top 10, but we are like obtaining probably around 2 million tons per year, mostly based on small pelagic fish, sustaining probably around 32,000 jobs and about 8.5 million of US dollars per year. This is, declining or decreasing the catch might have important impacts at the socio-ecological system. So we have several fisheries in Chile, different stocks. In northern Chile, we have anchovy and sardines. We have two administrative zones for these stocks. Then in central Chile, we have anchovy and aboriginal species, another sardine. And then in northern Patagonia, in the inner sea, we have also sprat species that all these species, they sustain a very important pelagic fisheries. And currently, the reference framework for this species is more or less this one. We have here the different levels of biomass from unexploited biomass. And then here we have the fish mortality. And currently in Chile, we have said that the target biomass is not 40% as in the maximum sustainable yield, but it's around 55% of the unexploited biomass. So this has been like tested with using MSE, management strategy evaluations, to explore whether this fish mortality is conducting to the objective in the long term. But the question still remains whether this is going to be an important issue for predators. Okay, so if still we are having enough food for predators. And as you see, we are more or less in between the more classical BMSY and this more conservative reference that is proposed by Smith and colleagues. So the question we have to ask, and what we were asked by the fisheries secretary in Chile, is whether these reference points were also ecosystem sound. Okay, so for this to try this or try to answer this question, we use previously constructed models, EWE models, for the same areas where these fisheries are developing. And we then use EcoSim. So I'm not going to go into the details for these equations. For any questions, we have Billy Christensen here. So I think I will be happy to answer any yeah, and any not really expert user might know these equations. But actually what we did, and I'm showing here, these are the one example of the food webs we built with these models. And to basically, here is, for example, the small pelagics here, the dominant small pelagic in this area, and also the different predators here. And then we feed these models to time series. So this is an example for the same system where we have less time series, but at least we have time series for the dominant small pelagic here. You see a very good feed. This is horse mackerel. Then we have feeds for some predators like the common sea lion, is another species of sea lions. And then we have feed to landings. Another example, this is the central south of Chile, where we have some more time series. So this is a feed to some squat lobster. This is the original or indigenous sardine, horse mackerel, anchovy, common sea lion, hake, and other species of squat lobsters and shrimps. So from these models, once they were like fitted to time series, we applied different fishing mortality scenarios. So one scenario is we applied non-fish. We run this scenario without, or this ecosystems without fishing. With this scenario, we get the unexploited biomass for the target species and also the unexploited biomass for the predators of those stocks. Then we applied the target fishing mortality is around the fishing mortality would lead the biomass to 50% of the unexploited biomass. And then we take the opportunity in Ecopath and Ecosims to estimate, fishing, the MSY fishing mortality with and without considering traffic interaction. So we have a Ecopath MSY without interactions and FMSY with full interactions. So we apply this mortality coefficients in the different models. Because of the time, I will also only show you a few examples. But then what we have here is that we have here the biomass after the simulation compared to the unexploited biomass obtained by the first scenario with no fishing. And then we have here the biomass, the relative biomass then for the different components. And so the black columns are the fishing mortality, the target fishing mortality. The gray is the fishing mortality obtained from Ecosim with fully interactions. And the white ones are the Ecosim MSY fishing mortality without considering traffic interaction. So the first, yeah, I'm finishing, yeah. So it's 10 minutes now already?
Less than 2 minutes. 2 minutes ago, we tried to tell you 2 minutes.
Okay, so this, if you look at the target species, then applying the fishing mortality will lead more or less to the objective. It's around 50% of the unexploited biomass, but we didn't observe like any collapse in the top predators or the predators of small pelagics. So the FMSY and fully single species and multi-species from Ecosim, they were a bit more aggressive, but still we didn't see like collapse in the other top predators. Other example, we found more or less the same trends in southern Chile for the common sardine. The fishing mortality will lead to the objective for the stock, but also we didn't see like a collapse for top predators. So remarks. Applying single species F target resulted in biomass around the objective and no collapse on predators. The current single species, or at least the ones that are considered in Chile, seems to be ecosystem sound. At least they seem to be a buffer for predators. And we should be revisiting both biological reference points as new information on the ecosystem is gathered and also the methodologies are refined. So this is, thank you.
We have time for one question. That's a really nice talk. We're seeing very similar kind of questions being asked with the management bodies we're working with as well. And I think it's quite common now that we're all dealing with questions around the importance of forage fish and how management can change. Something we've been tasked to look at and have been thinking about is how we can relate, because you said MSY is not necessarily the best thing to be aiming for, whether there are other objectives or policy reference points relative to the biomass of mammals and seabirds that we might be aiming for. And I was wondering if in your work you're looking at, how different levels of fish mortality might help to achieve wider ecosystem policy objectives.
Yeah, this is a big question because actually, as you mentioned, there's no agreement on how would you like that those predators by populations should be. So that's something we have to probably discuss with colleagues from the conservation, and also depends on what is the conservation status for each species. So it's not the same for one that is very conspicuous compared with other one that might be like in a red flags or something like that. But for example, there is this idea that you can classify the target species, I mean, the small pelagics according to the impact. So there'll be like species type 1 if one predator decreases beyond 75%, and then type 2 if there is 40 and 60, or type 3 it's not like really a key prey in the ecosystem. So we haven't solved that, but you can have at least this reference more or less from literature. Thank you very much.
Wait, what was that?
System model, as you said, maybe you need like a proper model to answer the question, right? So maybe we don't need like a very complex model to answer.
Brilliant. Next up, we have Dia talking about a systematic review of the use of food web models for addressing the social and economic consequences of fisheries policies and environmental change.
Hi everyone. Can you hear me fine? Yeah. Okay. My name is Dia, and I'm from the Norwegian Institute for Water Research in Oslo, and I'm an economist, not a modeler. But I am here with my colleague Santiago, who presented yesterday and who's also part of this work, as well as Enrico from CNR. So today we'd like to share with you some results of a systematic review we did on how food web models are being used to address the social and economic consequences of fisheries policies and environmental change. So on the left-hand side, you can see our search string that we used on Web of Science and Scopus, and also some from the personal archive. And on the right-hand side is a Prisma methodology flow diagram, which you might have seen before. And so I won't go through in detail, but the main things we were looking for is articles that have used socioeconomic indicators either as input or as output of models, used a food web model, and also not a review ideally, and of course relevant to our research question. And through a lot of screening process, in the end, we only had 47 articles that we decided to analyze further. And also just to let you know, when we did run the same search string without the economic terms, we had around 800 papers. So it was, yeah, a lot more. In terms of publications over time, so it has been increasing, but around 3 articles per year. And we know that the Ecopath literature is growing much faster than that. And also we wanted to identify if articles are how many functional groups they've defined and what fishing fleets. So the functional groups were defined quite well with around an average of 35. But in terms of fleets, it was not always the case. For example, 9 on average for articles. And sometimes they were also grouped as one fleet, even when we know that the case study area has more than that. So definitely need more information on that. In terms of study areas, so this is just a distribution of what type of countries and marine systems was most common. So you can see that the US is quite popular, especially from the California current. Around 35% of the articles were from there, and also the Europe with the Baltic and Mediterranean seas, as well as Asia, like South China. We also looked at like the Pearl River estuary, as well as not just marine, but also brackish and freshwater systems. So the results, we decided to divide this by research foci. For example, what the consequences are of implementing fisheries policies, of environmental change, climate change scenarios, and also papers that just characterized the fishery system with socioeconomic data. And then we wanted to analyze these questions through indicators. So, for example, food web model characteristics, what type of drivers they used, if that was fisheries drivers or more environmental, how they integrated the bioeconomic model, effort dynamics, also the optimization objectives. For example, if they're looking at maximizing profit or ecosystem maturity and performance metrics. So these would be based on ecological, economic, social, as well as fisheries. And ecological and fisheries, we are very familiar with. Economic as well, looking at profit and revenue. But social was more on employment. So this could also be employment by gender or sector, for example. And also, in terms of models, I would say that the EWE model was, of course, quite common with around 64%, but there were also others like Atlantis and mice models that used similar research questions. And many of these, they used their own integrated model component, or they linked and coupled with other bioeconomic models to address socioeconomic questions. And yeah, so this the first one would be on fisheries policies, and on the right-hand side is just the indicators I mentioned. So you can see that fisheries, economic, and ecological is very popular, whereas social not as much. In terms of the dynamics, it was mostly temporal with a few spatial as well. And also what type of drivers. So this was mostly direct changes in fishing effort, some looking at MPAs or no-take zones, and very few on seasonal effort restrictions. And yeah, like I mentioned, around 68% were used fully integrated instead of linking or coupling with others. Also, the effort dynamics was only 21%. In terms of objectives, maximizing profitability was the most popular, but there was also 18% on employment, stock recovery, biodiversity, and ecosystem maturity. But these were kind of the overall statistics from papers that focused on fisheries policies. And then moving on to climate change and environmental change. So for climate change, for example, they could be looking at the RCP scenarios, or also the impact of ocean acidification. What impact does that have on the socioeconomic? So they also use a lot of fisheries, economic indicators, very few social. So you can see that the story is a little bit similar here, also with direct changes in fishing effort. And there's also an additional component, which is the environmental drivers. So, for example, 60% looked at the Earth system model outputs as a driver, as well as abiotic factors. Yeah, and in terms, there's also mostly the objectives they looked at was mostly profitability and ecosystem maturity. In terms of environmental change, so this could be, for example, species invasion or change in habitat, and how that would impact the ecosystem as well as the socioeconomics. They also looked at fisheries economic indicators, mostly temporal, and change in terms of drivers, that was change in abundance as well as the Earth system model outputs. And again, very few did look at the fishing effort dynamics. So lastly, that we also looked at characterizations. For example, this could be value chain studies where they looked at the socioeconomics of a system. Of course, here there were a lot of social indicators as well, still not as much as the fisheries and economic side, and 100% of those were static because they were looking at. Sorry, there's a pop-up on this laptop that I need to close. Another meeting in 3 minutes? I don't know. Okay. Hopefully. Okay, that's good. Okay. Yeah. So yeah, and all of these were also 40% was coupled with feedback loops, and also linked with one directional feedback, and 20% fully integrated. We also wanted to know about trade-offs. So, if they did assess trade-offs, many papers did not. 32% of them did not, in fact. But if they did, what kind of indicators were they assessing? Was it between just ecology, or was it also between economic indicators and fishery? So you can see here that ecology and fishery was 78%, economy and fishery with 53%. So for example, this could be looking at implementing gear restrictions around coral reefs in Hawaii and how this impacts the catch of target species. But with economy, it could be a ban on illegal fishing in central Philippines, and compare this to non-target group abundance as well as net profits of the various fishing fleets. And in terms of economy and fisheries, they also looked at like the effects of climate change and nutrient loading, and compared this to the consequences in total yields and fishing profitability of the system. And this was a study in the Baltic Sea. And once again, the social side was not as much, I would say. With less, I think, comparison between employment and, let's say, profit, or employment and catch, or biomass. We also looked at uncertainty. And I think Santiago already mentioned yesterday that most of the uncertainty was around the biophysical parameters and less on the socioeconomics, and also more on parameter uncertainty. So like doing sensitivity analysis, and implementation and structural uncertainty was almost, there were almost none. So that would be, for example, if they looked at their model structure, or if they actually looked at how the policy would have an effect in reality. So I don't know if I went very fast, but yeah, in summary, I would say that, we've gone from managing fisheries independently to managing them as a whole, with ecosystem approach to fisheries management. And now we are looking at ecosystem-based management. And this means that we need to look at more than just fisheries, because we know that it impacts the community, it impacts the people, it impacts the economy. And just to summarize, from the review, we would say that it's important to define your fishing fleets, so to pay more attention to that. So to use available data to understand the cost of fishing as well, not just revenue. For example, if there's a cost change due to if this fleet is emitting less CO2, for example, and how that would impact. We also need to incorporate dynamics. So this would be like fleet dynamics, but also things like price elasticity. So how a change in price would impact demand, and also discount rate, for example, to calculate net present value, inflation, because all of these factors do have an impact on the fisheries and also the society. And then we have social and economic indicators, which I already mentioned, because it's also important to have this knowledge co-creation. And it was nice to see some presentations from today that did do that, but also to work with communities. And I know that the ICES is, for example, working on social indicators. So it is possible, as like Santiago mentioned, that you can use EWE to kind of implement this, but also to understand communities and how they behave. And maybe, the fishing is very deeply rooted in their kind of culture. So it also has an impact in that way. And also, of course, incorporate uncertainty, not just the biophysical, but also socioeconomic. And we hope that, by doing this review, we kind of give you a state of the art of what's already out there, which is also some really good case studies, but that we can do more, and also that we can work interdisciplinary and not just as an afterthought, but also from the beginning of projects. Yes, thank you so much.
Do you have any questions?
And yeah, great job, Dia. I have a question, because you're an economist and you have been trained as an economist. So you've been hearing in this conference lots and lots of really cool ecological indicators. Are you do they tell you something? What things do you would you have rather heard, or do you think would better inform choices to politicians or other people based on your training, which is, I think, the only one that is a full economist here?
Yeah, no, it's a good question. I think I've learned a lot these past 2 days, a lot that I did understand, a lot that I didn't, which is, it's fair enough. But I think it's really nice that we are looking at the ecosystem-based changes to fisheries and also the ecology. But it's also really important to, of course, there are some that you do look at revenue and cost, but it's also important to translate this into a language that policymakers understand. and also that they, care about, because everyone has their own set of goals and objectives and jobs, and we have to understand that. So to make an actual change, it's really important that the great work that we do, that it's actually applied, and I think it's important to make that connection with, having easily digestible, outcomes. For example, I've worked on like decision support tools where we translate the outcomes into very, easily digestible format that people can use that are not ecologists or fisheries specialists. Yeah, that's what I would say.
You have any more questions?
Thank you so much.
Okay, and now we have Marta again talking about linking sea and land systems through food web models and value chains, a portrait of the Ebro Delta.
Okay, thank you very much. I'm back on the stage. In this time, I'm going to present on behalf of the first author, which is Miquel Ortega, and also Elena Lloret. And here, the idea of this presentation is to show you some of the first results that we are getting, trying to move from our comfort zone. We have been working on these food web models in an area in the Mediterranean, and now trying to go into the value chain. So very nice to see the presentation before, and also the presentation that Santiago gave yesterday. Here we are in the Western Mediterranean. It's a very multi-specific fisheries, lots of small fishing fleets. And we really we have quite a good grasp of what happens in terms of the ecology in the area, but we had no idea on what happened after we catch the fish. So what's happened with the distribution, the processing, and the commercialization. So we wanted to start characterizing that. And also we wanted to start looking at the indicators and see if we could find analogous socioeconomic indicators that could complement the ecological indicators that we have. This is the area. It's a small area in the Northwestern Mediterranean. It's a continental shelf. It's quite productive for being in the Mediterranean. High seasonality, important fishing ground. As I said, we have 14 fishing harbors, 500 vessels around, and it's an important area, nursery area for small pelagics, and also for all other ecological features in the region. The model, what you have here, the specifications, it's not very important, the model, but it's a small model, quite highly resolved. And the link that we are trying to make with the value chain is through the catches of the functional groups and the fleet structure. Okay, so the data sources, we built a new model. So there were two previous ones, and we built a new model of a recent period, 2021, where we can find most of the economic information. And we used all the data that we could find to do that. So this would be the structure of the value chain that we are starting to parameterize. Here you have the fleet, so this is the catching, and then most of the time we stop here and we look at inside at the sea. But now we're starting trying to look outside in land. So what happens with the distribution? What happens with the processing and the commercialization? And for that we have been looking around for a lot of data. In terms of official for sale statistics, for example, we did a lot of in-depth interviews with the different actors of the value chain. We also access to some private databases on the businesses in the area, consumption official statistics, and grade and secondary literature. And then our final goal was really this, when trying to think of what kind of indicators we get from an Ecopath ecosystem model, and what kind of potential indicators we would get from the value chain, and see if they could inform complementary about different concepts. For example, the size of the system, the ecological sustainability, the key species, etc. So we have been going through this process, and it's not finished. So I would appreciate any comment you have about trying to match these indicators. So very, very quickly, I'm going to walk you through the results. This is common standard Ecopath. So we have our Ecopath. We have some indicators that are telling us especially we compare them to the models that we had in the past and the models that are in neighboring areas. We can say, okay, this is a moderate level of sustainability, a transfer efficiency area. The increase of the trophic levels is not showing an improvement, but actually a decline of the small pelagics and a big crash of the porcine fisheries. And there's low biodiversity and system omnivore index. So we know how to characterize what these indicators are telling us. We also have information, like for example, for the keystone species in the area. And here, this model is telling us that large pelagics, the cephalopods, and some of the commercial demersal fish are also important in terms of the keystone species. But also when we look at the revenues that I'm going to show you now, we find other species, like for example, anchovy, hake, sardine, red mullet, octopus would be also very important in terms of the revenues. So then we start, looking at the value chain. So after we catch them and we start distributing them, how this is the main fish flux of the area. And then we can start seeing some interesting patterns. For example, the big role that the wholesalers have in the whole channel. So there is an essential role when these fish come out of the water, who is commercialized, who is distributing them then to be commercialized. Also, the large scale retailers are very important in the area. And for our surprise, the fishmongers, which we thought that were really the essence of our value chains, have a modest or moderate role in the whole chain. At the same time, we also learned from this analysis that 93% of the fish production is consumed within the system, so we don't export that much. And actually, what we produce in the system only covers 20% of what we consume locally. So 80% of what we consume locally comes from outside. So this value chain doesn't include that, but you should have a big flow of importing products here. Another interesting thing that we learned looking at this value chain is from the first sell point, what is the role of these different actors in the value chain? And the first thing that we see is that it's highly concentrated in some important buyers. So you can see there that 3 buyers basically commercialize or buy in the first selling 40% of the volume of the catches. So they really control what's happening with the flux after. And there's 30% that in terms of value. So very few actors, when these fish are out of the water, are the ones that control what is happening. At the same time, we found that special high concentration for the porcines. So very few buyers control the price and control the revenues. And very interesting, there's very few active processors. So we don't process the fish that comes out. The fish that comes out directly goes and it's sold fresh in the market. So there's no processing activity in the area. And the food services, restaurants, bars, all these things that in the Mediterranean is quite important, has a very modest role in the first part of the value chain. So they don't go to the first sales to buy the fish. They actually get it much later on in the value chain. Interesting as well, we learned from the fishmongers that what they commercialize in their business, 3 out of 4, so 75% of the product is non-Mediterranean. So we try to, because we try to understand, okay, what makes you want to commercialize a Mediterranean product? They had several characteristics, but what they commercialize is mostly small pelagics, squilla mantis, so the mantis is squid, octopus, and red mullets and horse mackerel. The rest of what we eat comes from outside. So that gives a lot of interesting information to later communicate to the managers of this system. And to finish the results, I wanted to show you. Here you have 2 tables. This is the Gini index of concentration and tells us a little bit a similar result as before. So what is the dispersion of concentration of the catches in terms of the distribution? And you can see that it's very high. So this index normally goes from 0 to 1, and 1 means very, very concentrated. So, and especially for porcines, this role of key actors outside the water is fundamental to understand what's happening in this value chain. At the same time, very interesting as well, is that when we look at the contribution in terms of revenue, GDP, and job contribution, when you take the fish out of the water, at the end of the value chain, we see multipliers that are between 2 and 4, which means that what happens in the harbor is at least as important as what happens after the harbor to the consumption. And that's also very interesting because it puts a lot of questions of, okay, what is the role of these actors that we are not taking into account in the management of these fisheries? So I'm going to bring you to the discussion with some points that we have for discussion. We don't have the answers, but I'm very happy to discuss after with you. I think we know that from these ecosystems, at least the biologists, the economists maybe see different, but we know very well what the indicators are telling us. And but this is part of the story. If we want to start including these socioeconomic indicators through value chain of other analysis, we also need to find, that's my opinion, analogous indicators that tell us what's happening. No? For example, could be the jobs or the GDP indicators that we could start incorporating in our narratives. And in this context, this is not for you to read, but all the details. But what we did is that table that I showed you at the beginning. Okay, we had the ecological indicators, the value chain indicators, and then we have expected trends, what we think is expected in a system that would be resilient, that would be well managed. And then in red, you see the arrows that go on opposite direction, so that they are not doing as we would expect from the ecology, but also from the value chain perspective. And in yellow, you have those arrows, those indicators that are going in that direction, but it's still in very poor values or very low values. So the improvement is not enough. So we think that maybe moving towards this kind of frameworks where we can have analogous indicators that tell us, okay, from the ecological point of view, we are doing this. From the socioeconomic point of view, we're going in this direction, could be interesting. Although this is something that I put to the table to discuss maybe tomorrow in the workshop. Or maybe this is not relevant or not possible, but I would like to know the economist's perspective on this. The second point that I wanted to make is, okay, what should we consider a key fisheries species? We have, from the ecological point of view, we have the keystone species that we know that tell us that important species in terms of ecosystems. But if we want to incorporate the value chain, how we do that? And we have developed this very quick analysis where we plot the keystone indicators, for example, in one axis, in the x-axis, and the fleet revenue in log in the y-axis, and you can start finding some species that are relevant both from the economic and also from the ecological perspective. So we are suggesting, well, maybe these are the species where we're really require triple. So if you act on them, you're actually acting on the species ecosystem value chain benefit. So maybe we could start thinking about ways of identifying those species that are relevant in these different angles. Although we don't have to forget that there are species that are relevant because of the ecology that are not important economically, and the other way around. So it is not to suggest that we forget about the others, but maybe that we complement our visions. And the last thing that we wanted to discuss with you is we see that there's the fisheries management perspective of how it's happening in our area is basically a top-down with consultation process, or it goes through local management schemes when it's a more participatory, where we have fisheries public administration, scientists, and NGOs. But if half of the value chain, or at least between half and 4 times the actors that are outside are not included here, is this really relevant, or is this valid, how we are managing our fisheries? Or should we incorporate those actors of the value chain, like the distributors and the processors, that are also acting and are at least adding double the value or the same value as the others? This is something that we think the value chain can help at least highlight the importance of these actors that are now outside the fisheries management. And with that, I leave you. Thank you all for your attention.
Great stuff, Marta. This is very cool. I'm going to geek out here. So in this value chain, you have a lonja, right? So
Yeah.
like it's where you auction the fish. And
Exactly.
I saw that all the lines kind of merged, but yet you didn't include it as a stakeholder or like as an enterprise. And isn't it a broker? So like, isn't it getting something? And although it like the I guess the value ratio would be 1, but it does have a cost because like the fishing fleets do pay something for the lonja. And yeah, I was just wondering about that.
Yeah. Well, we actually, it's true that they are considered in the value chain, but because they are so much associated with the fishing activity, because basically in our region you cannot sell your fish if it's not through lonja. So it's actually the fish that goes or that landed is in lonja, and then it's sell. The first sell is happening in lonja. So that's why it's incorporated in the catching. Basically, they have a role, and maybe with Mikel you can discuss better how to make that visible. But the rationale is that it's really not something separated from the fleets. Yeah, it's a good point.
Thanks, Marta. That was great. I have a question on your last comment about we should include the rest of the value chain in our ecosystem-based discussions. I completely agree. But if you mentioned that you only eat 20% of the fish that you catch, so something like that, 80% comes from somewhere else. So then do we also need to include those value chains in those discussions? And then so the question, I guess, is, are we talking about managing the ecosystem? And if we're talking about managing the ecosystem, taking the whole ecosystem dynamic, the whole economic dynamics into account, how do we deal with the scale problem of a huge, a huge global food system that will have a huge impact on a very small ecosystem? So there's a huge scale difference between the ecological and the economic. And I don't know the answer to that, but I think that's something we really need to think about.
Yeah, it's very good question and crucial, because here this is a major problem. So we are managing something, but only contribute so much. The discussions that we are having with some people, we put it that way, is that because we are in a global market, and some people are catching up and doing things better than we do, their products are better. So in the sense of the Mediterranean, one of the problems of why they are not selling the local products is because the product is very small. Sometimes they don't get the volumes that they need to commercialize, so they prefer just go to the Atlantic products. And this is going to get worse and worse, because if we don't manage properly, we don't recover the stocks, our things are small, we don't have biomass. So this is also a way of telling them, guys, you need to manage properly, because otherwise the sardines, your anchovies, your cakes, is going to come from the Atlantic. But because there is product, it's just a question of if the consumers or the fishmongers are going to sell those products much better than the local ones, they will import them. So I think it's crucial. We need to take that into account. But I think as an argument to tell the local value chain that needs to be better managed. Otherwise, there's no chance for them. Yeah.
Thank you. I love that talk. And I really like this idea of sort of expanding the view of what we think of who's involved in the fishery. In the US, a lot of that, or an element of that discussion, I think, is also considering equity. So like which groups in there have more or less social capital, which groups have been more or less kind of empowered in the past. And I was wondering if that came up in this project.
Yeah. Not directly, but it's a question that we are aware of. And even we have made an analysis within the fleets. The fleets are very different. No, it's not the same, the small scale fishing that we have, than the bottom trawlers. So we have characterized their features, also in terms, for example, of the subsidies that they get, the good and the bad subsidies, and how they contribute to climate change. So this is a very relevant discussion that for prioritization of what the activity is fundamental. But we have done it, but in a parallel project. Yeah, thank you. Yeah.
Hey, up next we have Letitia. who's going to be talking about moving towards socioeconomic assessments for more holistic fisheries management.
So good morning, everyone. I'm Leticia. I'm a PhD student from University of São Paulo, Brazil. I'm here to present the work started with my supervisor, and I present for her, and I be part of the project, but she's the first author. So consider the fisheries management deserves multidimensional evaluations of the trade-offs involve the policy aiming to Sorry, is better? Okay. Considered fisheries management deserves multidimensional evaluations of the trade-offs involved in policy aiming to reduce fishing effort, the different fleets. A big project was created, funded by CNPq. It was a marine fishery call some years ago, titled Strategic Analysis for Ecosystem-Based Fisheries Management in the South Large Brazil Marine Ecosystem. And I will present the work we developed inside this big project. Our main aim was combining the ecosystem assessments into the ecosystem modeling and explore policy objectives under different scenarios. So our study area is the Santos Basin. The latitudinal limits correspond to the southwest continental south of Brazil and the state of Rio de Janeiro into the state of Santa Catarina. This region is characterized for seasonal upwelling, which support artisanal and industrial fisheries over the time. Our model area is in this map, the gridded area. Okay. So about the modeling approach, the new Santos Basin model that I improved represent the year 2018, but it was based on the previous model developed by my supervisor and collaborators in 2012. I highlight some changes we did in this new model. We included two new compartments, the striped tuna and dolphin fish, and more species was included in the different compartments too. We included 10 different fishing years, and we had a catch in the 4 time series from 2000 to 2017 for the fishing ecosystem model. So about the policy, the fishing policy sort data, we used the field-based economic data locally obtained by this big project, the ecosystem-based management. We obtained data from costs, fixed costs, profits, number of jobs, and fish price for all the 10 fleets. Here's the measure of all fleets, and I highlight in that way the mullet fleets, because mullets is a very important species in artisanal fleets in south of Brazil. So for the policy fishing search, we examined 4 different scenarios. The first one, we optimized the net economic value. The second one, social value. The third, ecosystem structure. And the last, for all the objectives combined. So as a result, here we have the biomass flow. 28 of the 37 functional groups are commercially exploited species. The high trophical level for the species was the long line. For the fleets was long line, and for the functional groups was tuna and sharks. And as you can see, the larger biomass comes from pelagic fleets and bent compartments. The model was fixed the time series of catch in the 4 data, and the vulnerability parameter used to run the policy routine was after the feeding. So these are the result from the policy routine. Each is the scenarios, with the 4 scenarios. The S1, the first one, is the profit scenario. And every time when we optimize some objectives, we put number 1 for these objectives and 0 for the others. So in the table, I put this here. In the first one, when we would optimize the profit, we can see that the economic has a really increase in economic. In the social, it can have a really small increase. things. Sorry, it is really small increase in social, but there is a decrease in biodiversity and ecosystem. You can see here in the table too. When we optimize the second one, as the social, S2, we have an increase in social, but we have an increase in economic too. But as the first one, we have a decrease in ecosystem and biodiversity. When we optimize the third one, S3, sorry, there was not an increase, neither a decrease in the ecosystem structure. They still stable, so they still in number one. But we had a decrease, a huge decrease in economic value and in the social value. And when we optimize the all combined, we has an increase in social. It's been a drop in profit in the economic value too. So when you consider the fleets after the optimization, this is a fleet change for the end and the initial and the end. In the first one, the profit, we have an increase in the polyline, percent, shrimp trout, and octopus boat at a stance of the other fleets. When we optimize the social one, we have the increase in polyline, percent, and shrimp is in expense of the others too. But when we optimize the ecosystem, we can see the decrease in almost all species in the red. But for polyline, there's not an increase nor a decrease. They can be stable. The effort can be stable. And when you optimize all together, the result is very similar to the first one. We optimize polyline, percent, shrimp trout, and octopus. And it means that the profit is pull the result. It's easier to increase profit than increase the ecosystem and these things. And when we will see the biomass from the change from the functional groups during the optimization, in yellow, we can see the first scenario from the optimization in profit. There was behind one, we are losing biomass. After one, we are increasing biomass. So we have a lot of decrease in almost 13 groups. Some of the groups stay a little stable, but we have an increase in large pelagic fish, deep demersal fish, and mullets. When we look to the social optimization, we can see a huge decrease for almost the biomass, almost to extinction. For example, in sharks, ray, we have a really, they disappear in the ecosystem. But we have an increase in 3 deep compartments, deep sea demersal fish, deep sea crab, and benthus, Betetivorus benthus. In the S3, in the green, sorry, when we optimize the ecosystem, the measure of the species stays stable and the biomass during the simulation. Just octopus has a little decrease, but very small decrease. The others stay stable, and we have an increase in mullets too. And the last one, when we optimize the altogether, S4 in blue, the result is really similar to the first one. The profit has almost 10 groups that decrease completely, like sharks, rays, octopus, the hake, and Brazilian cod. But the others stay a little stable. And we have an increase for 3 species, like the S12, like pelagic fish, deep demersal fish, and mullets. And to conclude, we can see that most commercial spotted species have decreased biomass after the optimization, especially from the socioeconomic objective. But I think for the social was worse. Polyline is the only fleet that does need to reduce effort when optimizing the ecosystem because they can be stable. And mullet is the only group that increased biomass in 3 of the 4 scenarios, except for the social value. And it seems critical to develop alternative livelihood indicators for stimulating economic performance by fisheries management and conservation policy. So I really want to say thank you for the, So for the VLIS and for the Ecopath organization, because I'm here because I received a funding to be here. So I'm really grateful for that. I want to say thank you for CNPq because I received the DT scholarship for working on this project. And the university I study for all sport and my lab because this is not my work, it's a group work. So I really say thank you to everyone. Thanks.
Given that I'm possibly the only one in the room that actually has run these, except for Willy, maybe. I don't know if everybody else has done these optimizations. Yeah, us old people have done it, but the new guys haven't done it because they've forgotten about it. But my question is, I maybe I missed it. How long did you run the simulations for?
18 years.
18 years. So I think I came in.
It's for an
18 year. Oh,
simulation.
I wasn't paying attention. Yeah, so I think that's probably why you don't see that much of a difference under the economic or the ecological scenario, because it takes a much longer time.
Yeah.
And one of the other things I remember from when we were doing this is that sometimes if you run it past the simulation time, you get collapses, especially in the economic one. So it basically pushes to catch all of the things that make a lot of money, but then in year X+1, everything collapses. So I don't know if do you remember that?
20 years beyond.
Does it?
Oh.
Okay. It does that automatically. Okay. Thank you.
Thank you.
Great talk. I don't have a question, but just a comment. I've run the policy optimization before. It's been about 15 years. I know exactly, and I think I ran it in Ecopath 5. But one of the things that I did, and I think you could take this a step further, is what this does is it really identifies that trade-off between conservation and economic management objectives. And where you've done just the ones and zeros on the objective function, if you iterate through that and do intermediate values between 1 and 0, you can actually generate this trade-off curve, right? And it kind of shows where you can potentially maximize, have both high conservation value and high profits. And so I suggest you maybe take a look at that. Ecopath 5 had like a batch processing thing where you could actually set that up. But I don't think it made it into the Ecopath 6 or not. But I actually went back to Ecopath 5 so I could use the batch processing. But it was actually very revealing, because then you sort of have this trade-off curve, and there's this set of policy options up here where both values are high. You can kind of start to focus on like, okay, what are the effort combinations in this optimum area? So just a suggestion if you want to take this a step further.
Thank you.
I think this indicates a need for more specialized courses, doesn't it? Well, there's so many cool tools in Ecopath that you don't see often, and just knowing that they exist and getting some good uses in them. Let's talk.
Thank you.
11 papers. 11 papers. Okay. You didn't publish. 11 and a half.
Okay, thank you again.
Okay, now we have Vincent. Vincent's going to be talking about advancing offshore wind farm development, case studies in France, demonstrating Ecopath with Ecosim utility for management decisions. Did you manage to?
So, hello everyone. I'm Vincent Faure from France Énergie Marine. France Énergie Marine is the French Institute for Energy Transition, dedicated to marine renewable energies. And I'm working in the ecosystemic approach division, dedicated to study the socio-environmental impacts of these kind of technologies, including offshore wind technologies. So today I will presenting how we utilize the Ecopath with Ecosim framework in order to analyze this impact and discuss also the relevance of our works for an operational ecosystem-based management. So this will not be a very technical presentation, but I will mainly focus on the methodologies we are using. And first, I would like also to thank the co-author who contributed to preparing this presentation. So a little bit of context. So considering the process of reducing carbon emission in the energy sector, the offshore wind farm technology is growing all over the world, and especially in Europe. The French government has planned to develop offshore wind farm in the next year up to 45 gigawatts in 2050. And in the map here that you can see, this development will lead to an important spatial use of the marine space on each marine French facade. So it's a figure with several impacts of offshore wind farm development. So a growing concern is emerging on the potential cumulative impacts at different spatial and levels. Cumulative impact of the offshore wind turbine and also other human activities on the functioning of marine ecosystem. So as a consequence, French public authorities is coordinating a working group called GT Écume. It's a group of experts, and the objective is to propose a method for assessing the cumulative impacts, the cumulative effects of marine renewable energies project on biodiversity and marine ecosystem. So one of their recent recommendation highlights the need to adapt an ecosystemic modeling approach for these technologies. So in fact, at France Énergie Marine, we have not waited for this recommendation, and between 2015 and nowadays, we have managed several collaborative research projects that link ecosystemic approach with the study of the environmental impact of wind farms. So in this study, we are mainly using the Ecopath with EcoSim framework and also the ENA ecological network analysis. So in this presentation, I will first briefly say a word about the ENA indices, and then I will describe some projects we have completed or are currently underway. The two projects with cumulative impact, about cumulative impacts, and one other project about the chemical risk. So first, a few words about ENA. ENA indices can quantify emerging properties of ecosystem and monitor their evolution, and it offers a quantitative assessment of marine ecosystem functioning. They allow to study changes in the structure, functioning of ecosystem subjective to pressures. Safi et al. In 2019 have presented a framework based on ENA for the development of ecosystem-based indicators for decision makers. The usual way to use ENA is a static way with an Ecopath model, for example, or with the LIM algorithm. But in our recent project, our team and partners have developed a way to evaluate time series and maps of ENA. So using ENA with spatialized ecosystem model make them more operational and could help marine spatial planning. I will give an example afterwards. So let's start to talk about the Trophic project. It's one of the first project about this subject. The objective was to establish the foundation for an ecosystem-based approach for offshore wind farms. Using the example of the Courseulles-sur-Mer offshore wind farm in Normandy in France. So first here, you can see in this figure the two main effects of an offshore wind turbine. The reef effect, the effect refers to the creation of artificial habitats that attract marine organisms, and the reserve effect. This effect refers to the spatial restriction, such as exclusion zone for fisheries activities. So during its work, Aurora Hooks, during its PhD work, she has developed an Ecopath model on this area. and started to produce scenario with and without a wind farm. Then Halwani et al. Developed an ECOPSIM and an EcoSpace model in this area in order to investigate the potential spillover effect of the presence of a wind farm. So based on this work, specialized ENA indicators were computed both for the reference system and for the scenario with the presence of a wind farm. And so they permit to assess a spatial analysis of the evolution of the ecosystem properties. So it's the work from Emma Arrhenius and then the work of Quentin Nogues. So now I will talk a little bit about the work of Quentin Nogues, because during its PhD, he continues the development of this ecospace model of the Seine Bay. So in his work, he studied the cumulative effects of climate change and offshore wind farm using, again, this specialized ENA. So he has shown that there are various cumulative effects between ecosystem properties with multiple mechanisms, and he's also shown the spatial and temporal variability of this effect. And so we think that there is a direct application to public policy as these results permit to contextualize the effect of a different temporal and spatial scale. So let's move to an ongoing project called Nestor. So this project is in continuation of previous one, but one of its originality is the first objective. We are conducting, in fact, a comprehensive analysis of the French national strategic documents for marine ecosystem management, because a better understanding of this functioning of the governments will allow a marine modeling expert to adapt their tools to the legal and institutional context, and thus proposing decision support tools that are tailored to the situation. So in continuation of the previous project, we will also develop a set of nested trophic modeling tools using Ecopath with EcoSim software at different spatial scale and in several other areas. So the English Channel, the Mediterranean Sea, and also in the southern Brittany. So this model will permit to produce different management scenario integrating both local to regional stakes. So now I will talk about another specific issue of offshore wind farm technology. It's the chemical risk, linked in particular with the cathodic protection. So we are studying this issue in a project called Ecopath. So what are the reasons of this project? So it was a response to both societal and institutional needs, because as evidenced by various online articles, there have been controversies surrounding concerns about aluminium, with alarming statements such as, "Soon you will have aluminium in your plates." So one part of the project is to conduct a chemical risk assessment of elements released by this galvanic protection, cathodic protection. And another one is to upgrade and develop model in order to simulate the dispersion of these elements in the marine environment, and then to investigate the spatial trophic transfer of them in food web. So what is our methodology? For this case study in Ecopath is the Gulf of Lions. So we are using an Ecopath EcoSim EcoSpace model called Golem. The Ecopath model was described in a recent paper from Seyer et al. In 2023. We are working on the development of an eco-tracer for the aluminium. We will then use simulated dispersal maps of aluminium coming from both the environmental concentration and the concentration from the rivers, and also the concentration coming from the offshore wind farm decomposition of cathodic protection. So we'll then be able to study the transfer of aluminium along the food web. And at the end, we will bring information for both society and public authorities. So I would like also to mention that we are thinking with Natalie Nikhil to use ENA with contaminants. It means that we will use ENA with contaminant units and not a biomass unit as we said. So it's really a work in progress with Natalie. To conclude, we have shown that the EWI framework could be a useful tool to study the impacts, including in the context of offshore wind farm development. And we think it is relevant for an operational based management. I want to add also that FEM and its partner will continue to develop and manage collaborative projects dealing with ecosystemic approach with Ecopath ecosystem. And so I have heard yesterday that about the Eco Mode Wind initiative from Christy Lewis. And so I think it's really a great opportunities to start to collaborate. So thank you for your attention.
We have time for one question.
So first a statement, I really like the title of the Gulf of Lion Ecosystem Model column. That's really good. But also do you have a sense for what's the flow of aluminum coming off of these to feed into like an eco-tracer model? Do you have even measurements on that yet or
measurement
or some estimate of
aluminium, yes.
sorry, aluminium, sorry.
Aluminium.
Spoke the wrong English.
Yes, yes, but aluminium in the food web, it's not really a contaminant studied, in fact, in the marine environment because it's not really considered as a contaminant. So it's really hard to find a lot of data in order to parameterize Ecotracer. So we are working with the Mediterranean Institute of Oceanography in Marseille, and they have some data of aluminum concentration in fish and in phytoplankton, zooplankton with different size class. So I have some data, but for the moment, the Ecotracer model is not ready. So, but it's quite hard. Yeah, it's true. But we have to study aluminium because, as I said, this was really a societal demand. So.
Yeah, a quick comment. I mean, this spatialized ENA indicators, you can do it too. There's a plugin in EcoSpace now, the ENA R plugin, that extracts input files for the R package of ENA to do this yourself. And we want to extend that to Ecopath and EcoSim because network analysis can take long to run. At least now you offload that. So that's something you can do as well.
I'm very excited by this group's work because they actually doing the ENA spatially, which I've been wanting since, EcoSpace came out. So thank you. So thank you for nothing.
Great. So next we have Sarah. She's going to be talking about applying the Ecopath approach for planning, developing and monitoring wind energy projects in Germany.
Hello, everyone. Thank you for having me. Today, I'm going to take you into a different world. So we're going to talk about wind energy sector in Germany, and we're going to go on land. So it's going to be about onshore wind. Yes, what's crazy? Okay, what I'm going to present today is I'm going to give you a short overview of the legal situation that we are facing in Germany and the problems that we are having. And then in point 2, I'm going to explain to you why I think that the Ecopath approach is the right solution for our problems. And last slide will be about Iberdrola, why Iberdrola is interested in this approach. So I'm going to give you a short introduction about myself. My name is Sarah Fretzer. I'm currently the team lead of the team Environment and Land Planning at Iberdrola in Germany. So I did my PhD in ecosystem modeling, and I presented how to use Ecopath as an environmental impact assessment tool a couple of years ago in Barcelona. I still think that we need to close the gap between science and business because we have to fight the climate crisis and also the biodiversity crisis. And I think from my perspective, the Ecopath approach is the right tool to do that. So I'm working for Iberdrola in Germany right now. We are working onshore and offshore, wind and PV, hydrogen as well. So we're covering everything in regard to the renewable sector. So we have 100% green energy. The Iberdrola group is a little bit different. Iberdrola, honestly, I didn't know what Iberdrola is until I had my job interview. So it's one of the biggest companies in the world. We have over 36 million customers and more than 40,000 people working for us. So it's a big company, which also means for me that we are the ones that may be able to tackle this challenge. So let's talk about the situation in Germany. The first law I'm going to present to you is called WindBG, which is the Wind Acceleration Act in Germany. We have a big push in the energy market due to the war in Ukraine. So Germany was highly relying on gas and oil from Russia, but there's now a big transition into the renewable sector, which also means that 2% of the land area shall be designated for wind energy. This is defined for each federal state, and we call it wind priority areas. There's going to be two steps. The step one is we have a baseline until 2027. So in the column C on the left side, the federal state, and the second column is step one with a land area that is designated until then. So you have values between 0.25, or the highest one is Thüringen with 1.8% of land. Then the column that follows to the right is the benchmark until 2032. And on the right column, you see the total area per federal state that has to be designated for wind. So everyone's rushing right now to get wind priority areas, and the big approach for these wind priority areas is that we, as Iberdrola or the project developer, we don't have to do environmental impact assessments anymore, which usually take between 1 or 2 years, and they're very expensive, and there are big discussions about them. We don't have to do it anymore. The government now has to do it. So all the municipalities who are in charge of these wind priority areas, they have to perform this assessment. If they have no data, or if there's no assessment, it means that they don't have a real solution for this. It means that we have to pay. We have to pay a certain amount of money, which is already defined in the law, which is 450 euros per megawatt, or depending on the case, it can be 3,000 euros per megawatt, which is, by the way, not a lot of money. So each centimeter in Germany is part of a plan. This is also defined by law, which is the Regional Planning Act, or ROG. So how do you get an area to become a wind priority area? As you see on the right side, you have all different kinds of goals there. So you have green stripes that can mean it's a designated area for grassland, for agriculture. In red, you have electricity lines. So everything is in there, in those plans. So if you now show up and say, okay, we want to do a wind priority area here, that means they have to change the goals of the regional plan. And usually they're not really excited about it because it means a lot of work for them. We call it tough procedure, which means you have to change the goals of the plan. And you have to hand in a lot of documents, a lot of assessments, a lot of legal statements in order to make it happen. What's interesting for us is Article 7 of the ROG, which means if you have a priority area for grassland, which is, for example, the green stripes that you see in the middle of the picture, and now you see, okay, this is grassland, but we want to do a wind project here. If we can demonstrate, for example, by using EcoSpace, that the functioning and the characteristics of the grassland ecosystem are maintained, we can do both, and then they don't have to change the regional plan. So this is what we're aiming for at the moment, and I will come to this later. When we look at the wind sector, we also have to look at Europe. Europe just announced RED 3, which is the Renewable Energy Directive 3. They are now coming up with acceleration areas for renewables. So this is not just covering wind, it's also for PV. Why are they doing this? They want to speed up the process. They want to push the renewable sector in entire Europe. And they want to make it easier for project developers to get a permit. So how do they do that? They define areas that are taboo, for example, national parks or FFH areas or bird reserved areas. So you're not allowed to go there. you are supposed to look for conflict-free areas, which is not easy to find in a small country like Germany. And again, the environmental impact assessment should be done by the municipalities or authorities. So the project developers are completely out of the loop with this. But if there's no data, which is the normal case actually, because they don't do a lot of mapping and they don't do a lot of environmental studies. So if there's no data and they don't have an assessment, again, we have to pay. And there's another problem with this because we have a biodiversity crisis, but with those acceleration areas and with RED 3, we are only looking at the species that are protected by the Habitats Directive or the Birds Directive. So those are the two EU laws that will cover the biodiversity conservation aspects. All the other regulations, like red list species in certain areas in Germany, no one cares anymore. So we will only look at those laws and we'll only look at the species that are listed there. So let's go back to Germany and let's move away from the wind priority areas. So in Germany, we have something that is called BNHG, or the Federal Nature Conservation Act. In Article 44, it says that animals must not be disturbed, which is a big problem for wind turbines because they make a lot of noise and they make sound and they make a lot of light pollution as well. So we have a lot of court trials where experts say, okay, you disturbed a species, so you will not get a permit. But we have to look at not only individuals that might feel disturbed, we have to look at the population status. And this is something that is not done today. So this is something that we could do with EcoSpace, but I will come to this later again. According to Article 44, it also means that breeding sites and resting sites must not be impacted or destroyed. And also, it is forbidden that animals are killed. So we do have a collision risk with wind turbines. We are fully aware of that. But there's a level of significance. That means if the mortality risk is increased significantly, and this word is really specific in the law, then you will not get a permit because you're violating Article 44. But the big question is, when do we have a significant increase in mortality? So mortality risk, sorry. So the government came up with a solution a couple of years ago. This is also due to the war in Ukraine. They created Article 45B, which means that we will look at the distance between a turbine and a nest. So we have 3 circles around the wind turbine. We have the red circle. That means here you have a highly significant collision risk, which means you will not get a permit. If the nest is a little bit more outside in the yellow area, that means you have a significant collision risk. But if you undertake certain measures, you can get a permit. And if you look at the green area here, officially the collision risk is not significantly increased, but maybe you have a bird that is nesting outside in the green area, but it feeds a lot in the red area. So this may increase the risk up to the benchmark of significance. So this might be critical. So in this case, you have to make some investigations like HPA, which is called Habitat Potential Assessment. And I will come to that later again, which is quite critical. But in these cases, you might be lucky and get a permit, and otherwise you might be unlucky and not get one. So the Article 45B solves a lot of problems because when do we have a significant collision risk? And this has been a discussion that's been going on for decades. And on the left side, you see the bird species. And then you see with the red circle, you see the red benchmark. And then in yellow, you see the yellow area. And green, you see the green area. So with red, we have distances between 400 and 1,500 meters, depending on the species. Yellow goes from about 500 to up to 3,000, sorry. And then you have the green area, which is between 1,000 and 5,000 meters. I will hurry. So the question is, are those, let me go to the next one. The question is, are those distances valid and is this really working? So what measures can we undertake? We have anti-collision systems. We can turn off the turbine during agriculture and so forth. So we have a lot of measures that we can do, but there's still a lot of discussion going on. And interesting, 6 or 8% of the annual income limit is a benchmark. And once we reach those values, those euros, we can run without any impact. So this is also reflecting this. Germany has failed to implement the Habitats Directive effectively. So it was sentenced by the European Court of Justice last year in December and also in September. And also there's an ongoing procedure right now because Germany is failing to protect birds and violating the Birds Directive. So we must enhance biodiversity protection and fight against climate change at the same time. So this is my approach for a solution. First of all, we've got a list of breeding birds colliding with wind turbines, but in Ecopath, we can increase all the species that are inhabiting the area, so we don't have to rely on this list, and we don't have to leave something out. Level of significance, we can calculate via EcoSim. We have different mortality rates, so we can just compare. Right now, it's just verbal argumentation. So someone says it's increased or it's not, it's significant or it's not, but we can show data. And this is something that we don't have so far. Regarding the disturbance, we can include shape layers with light and noise, sound pollution in the model. And then we can again have a look at the population levels, which we are not doing right now. What is important for a business? We have to calculate the impact and also how to compensate it. This is crucial for us. So this is something that we can do with this approach. We have 16 different federal states in Germany. We have over 300 planning regions, and they all have their own ideas about what's going on. But with EcoSpace and the Ecopath approach, we have one approach that fits everything because we can adjust like they want it, and then we can come up with the results that we need. HPA, I wanted to say that again. This is a tool that was requested, and my idea was that EcoSpace can handle this. I also saw that we have a habitat suitability index. Right now, we have the numbers between 1 and 5. So for example, if an owl species lives in a forest, they're highly correlated, so it would get number 5. If the owl species is looking for a desert, it would get the number 1. So this is what we're having right now. I mean, everyone in kindergarten can do something like this. And I think with the EcoSpace approach, we can get much better results and much higher value than what it's done right now. Also, in regard of planning, we can take a look at the different wind farm layouts. We can move the turbines around and see what is the layout that is really sustainable. And also regarding monitoring, we have a lot of keystone indexes, and we can have a look at the data to see what is really critical and where do we have to do monitoring. Right now, it's just negotiated. And why does Iberdrola want to do this? Iberdrola is, you can see it on the bottom. I put our websites here. Iberdrola is listed in the New York Sustainability Index, and it's listed in several sustainability stuff. So right now we've got a AAA score there. So Iberdrola is really looking forward. In regard to biodiversity conservation, we've got the Biodiversity Action Plan, which means that by 2025, we must have net zero impact on ecosystems and biodiversity. So we also have to create a biodiversity action plan for each species that is critical in the area, which I think is a good tool for EcoSpace, because then, or EcoSpace is a good tool for this, because then we can see in the model, what is the model telling us and what do we need to do in order to make sure that these populations are not decreasing. By 2030, this is really interesting, we must have a net positive impact on ecosystem and enhance biodiversity. And honestly, right now, we don't really know how to do that because we get a lot of instructions from the municipalities for our permits. We do a lot of monitoring, but how do you ensure that you have a positive impact on the ecosystem for your model, for your project? And I think the Ecopath approach and the model might help us here to see what needs to be done, like mixed trophic impact routine, or what scenarios do we need to do in order to make sure that that we can deliver here. So we also have a net deforestation policy. So every tree that gets cut has to be replanted. And we also have a crime prevention program for birds. So we want to use anti-collision systems to make sure that we have a minimum impact on the bird species in our projects. And that's it. Thank you.
Thank you for presentation. I was just wondering, what did you define a positive impact? How did you define it?
Positive impact is everything that enhances biodiversity species in numbers and also in biomass.
For example, in this definition, an invasive species add to biodiversity, right? Because one species increase biodiversity.
Yes.
So this is positive or negative?
We haven't thought about the details, but let me also explain the reason why I'm here. The reason why Iberdrola sent me here is because we want to set up a pilot project. So we want to have a look at this, and we also want to have a look at the different scenarios that we can run in a pilot, and then we will see how we move on from there.
You may wonder why is Sarah here when she worked with terrestrial system, but she's really taken an interest in working with Ecospace for quite a while, including at the 2014 Barcelona conference. And I would like to thank you for coming. And I really appreciate it. And I would also say we've been in communication with Sarah for a while, and we are looking for someone to interest in terrestrial modeling terrestrial ecosystems. So job perhaps.
Yes. And also, I would like to point out that we do onshore and offshore. So Iberdrola is also interested in using this tool for our offshore wind farms. And I know there are a lot of models already out there, but we would have to have a look at this for our daily needs, so for our workflows, for our projects, and also for the discussions that we have in order to get a permit. So these are really long trials. We are talking for a normal wind farm up to 8 years, and so from the beginning to the end, till it's really up to construction. So we would like to speed this up, and we would like to speed it up without damaging the environment and without harming the biodiversity. So this is crucial for Iberdrola. This is why we are listed in all those indexes. And I'm hoping that with EII, with Willy and Jerome, that we will move forward here, and we will hopefully do this very quickly. Thank you.
Thank you very much. Brilliant. So we're running slightly over, but luckily it's me next. So I'll try and get some time. I think Angela's going to let me know when we get to 8 minutes. So I'm going to be talking about how we're using Ecopath with Ecosim and ICES. So there's been a lot of projects discussed here, a lot of work that's been shared that would suitably fit into existing intergovernmental advice. So I'm going to show you how we've been doing it and kind of give a brief of what ICES is. I've been talking to a few of you over the week about ICES and how we're engaged, but hopefully this will give you more of an insight into how you can get more involved. So firstly, what is ICES? So ICES is an intergovernmental marine science organization. It's a network of volunteers, essentially, and they are a knowledge provider to policy formers and decision makers. So you can see on this map some of the requesters of ICES advice. So these guys are signed up to receive information on how much they should catch every year, also information on the status of the ecosystems. So we provide a lot of this information, and this includes the EU and other governments and also stakeholders. And it's also a marine leading data center. So a lot of our data that we want can be found within some of the ICES databases, and we can also contribute to these data sets. On the bottom here is a lot of their science priorities, and they align pretty much with everything that we've been talking about this week and everything that we know we can do with Ecopath, with Ecosim and Ecospace. So who is ICES? So ICES does have a structure based out of Copenhagen. There's a council at the top, and then there are these two committees, the Science Committee and the Advisory Committee. These were chaired by Jorn Schmidt, chaired the Science Committee, and Mark Dickey-Collis on ACOM. But recently they've stepped down, so we have some new chairs of these regions. We have Colin Lorden, who's now the chair of ACOM, and Dave Reed, who's the chair of SciComm. Both of these people are very ecosystem focused and have worked with Ecopath, with Ecosim in the past, and are very interested in driving forward ecosystem-based management and ecosystem-based fisheries management. So it feels like a time where things are moving. We've been talking about it for a long time, but things are changing. So it's a good time to start getting involved. Underneath this, we have some expert groups, which is what we can get involved with. And these provide science and advice that feeds into ICES advice and science. Overall, there are about 6,000 experts, quite a lot of who are probably in this room, a few of who are in this room, not 6,000, who's been or is a member of an ICES working group. There you go. So if anyone is interested, just find these people and they'll tell you about their experiences within ICES. There are over 150 expert groups contributing from over 60 countries, and they feed into knowledge. So we generate science that feeds into advice, but often the science doesn't necessarily go straight into advice, but down the line, that science is there to influence advice. But most importantly, so this is the structure. we are ICES. My favorite quote about ICES that I heard not too recently is that it does not exist. And what that means is that without... They didn't like that comment. It exists, I promise. But what that means is essentially it doesn't exist without us, without the voluntary work we put into it. And if you're interested in seeing your advice, seeing your science make its way into advice products, it's a good process to get involved with. And there's lots of people here that you'll probably recognize, many of who haven't made it this year. But these are a lot of groups that include Ecopath with Ecosim models. ICs love acronyms more than anyone else I know. So I don't expect anyone to know all of these, but these are working groups, steering groups, and workshops that are actively using Ecopath with Ecosim models at the moment. So the ones that are kind of dark blue, these are steering groups. So ICs have a human dimension steering group that look to incorporating social and economic information into advice. There's an ecosystem approach and method steering group, which deliver ecosystem overviews, what the status of ecosystems are. You have your fisheries resource steering group. These are in charge of delivering stock assessments and stock advice. Then you have HAPPY, which is human pressures and impact steering groups. They look at things like wind farms and fisheries and how they interact with the environment. And then you have all these groups around them that stem from that. So these ones here, these are workshops that have all been looking to develop ecosystem-based fisheries management advice using EWE. Around here, a lot of these are integrated ecosystem assessment steering groups for specific ecoregions, and they give ecosystem overviews. What else do we have a group that's in the end of this year, and a lot of people should go, WK participatory modeling. It's how we develop ecosystem models with stakeholders. ICs want to formalize how they should do that and develop a framework because it's happening across the network, but also often with limited support and limited consistency. So we're looking to see if we can improve that. So get involved. There's a website that's just gone up. If you Google WK participatory modeling, it's in October. And then a little while ago, there was a workshop called WK EO3. And this was about ecosystem overviews and how we can incorporate information into them. So ecosystem overviews are products that the EU and other people request to inform them on the status of ecosystems so that they can guide their own policy management decisions. And from that, they decided that a lot of the things they needed to integrate into these ecosystem overviews was based around food web knowledge and also carbon, which we've been talking about, escapes ecosystem services. So we are using Ecopath Ecosim in all of these. We're using Ecopath Ecosim to look at how our activities impact ecosystem services. So this links through to the stuff that Santiago was talking about. But I'm going to focus in here. You'll notice a few of them recently as well, actually, have started to move away from acronyms, so it's not too bad. We have food web, fish carbon, participatory modeling. So there's a shift. But we're going to focus on WK Food Web, which happened earlier this year in Copenhagen. And a lot of people here were also there. So this was chaired by myself, Maciek, Ida, and Marian, who aren't here at the moment, but maybe watching online. And we had a few terms of reference. The idea of this group was to formalize how we start putting food web information into IC's advice, because requests are coming thick and fast from the EU and other requesters, but often are we ready to deliver that information? We know we have the science and the advice, but are we in a position where we can rapidly deliver that? And the answer is probably no. So we have a few terms of reference as part of this group, and the report's underway. We're looking to supply ecosystem indicators, describe the status of the ecosystem. We're looking to develop pipelines to feed information through to advice. We're looking to be more systematic about the way we develop food web models. So what can we learn from each other? How can we share information? A lot of the stuff that Holden was sharing. And we want new products to go into these ecosystem overviews to requesters. We want to be able to describe the state of the ecosystem to them, but also point out what questions they should be asking of us. Because there's often this disconnect. We have all this ecosystem information, but they don't necessarily know what questions to ask us. So they just continue asking for what they've always been asking. So food web advice that we've been giving. So we've been linking Ecopath with Ecosim through to catch advice. 5 years ago, I discussed the FECO approach. So this is an ecosystem-based fishing reference point that we developed via ICs. What this allows you to do using an ecosystem model, you can look at a specific stock where there may be problems, it may be suffering, and you can link its production to certain drivers using EWE, like a lot of us are showing today. When you can identify these drivers, you can then link it through to stock assessment advice. So for a lot of stocks, ICs provide fishing maximum sustainable yield advice that goes between a lower and an upper range. And the idea is that you can start scaling your advice within this range based on the condition of the ecosystem. If the ecosystem's in a poor condition, fish towards the bottom because you want to reduce your cumulative impact. If the ecosystem's great and you expect high productivity, maybe it's okay to go towards the upper range. So that's one approach that we're doing at the moment. And I think a few people in this room are developing reference points. I know Xavi's working on something like that. But ICs also have now got conservation advice in their stock assessments. So we can take qualitative information from EWE to inform ecosystem-based conservation advice. There's also a lot of work going on with management strategy evaluation. We've had a couple of talks in here that have kind of been MSc adjacent, where you have an operating model that feeds into a management procedure and creates like a feedback loop. But we're looking at how we can input ecosystem information into this. So this is normally a process that tests the robustness of existing catch advice. So looking at single species management, single species assessment models, throwing extra uncertainty at them to see if they stand up under change in the future. And we want to look at whether they stand up to change in the ecosystem and whether we can use performance metrics to describe or to evaluate the success of our strategies. So not just the traditional performance metrics like achieving MSY or good yields, but leaving enough food for predators and things like that, which a lot of requesters are asking for at the moment. And then there's the ecosystem overviews. And this is where we want to start informing decision makers of the information they can ask for. So this is a concept that the group WK Food Web put together. So the requesters are interested in knowing about the flows within the ecosystems. And it's a weird stalemate. We hear it quite a lot from people that EBM and EBFM hasn't proceeded because no one's asking for it. But then at the other side, they don't know what to ask for. But then as ICs, we're not supposed to tell them what to ask for. So how can we start putting information into our products that highlight, you need to think about this, temperatures impacting cod in your ecoregion, or forage fish biomass is a real problem for this seabird species. So we're trying to open up these conversations. And then we're really focusing on food web modeling. So again, a lot of the stuff that Holden mentioned, we want to improve documentation within ICs. We want to improve transparency, sharing code. We want to make systematic skill assessments. So within ICs, you can get models which are referred to as key runs, where they've been through a review stage, they've produced a report. Angela is working with me to produce a automated key run report, so we can put our Ecopath and Ecosim inputs into it and automatically generate a key run report. Yeah, and then we're looking to formally streamline review. At the moment, models are reviewed through WGSAM, which is a working group for multi-species assessment methods. They meet once a year and have capacity to review 2 models. If a requester came forward and said, I want ecosystem-based reference points for all of these stocks, there's no way this group has capacity. So we're looking at developing a new group called WG Eco Hub. And the idea of this group is to formalize ecosystem information and push it through to advice. So ICs have got advice groups and science groups, but this is an action-based group. So it would be not necessarily developing science, but making those links between science and advice. So this is just a forward look. So what we're seeing now coming from requesters, it's information on cumulative impacts, offshore wind, fisheries, what the needs of predators are, spatial planning, trade-offs, and projections. This is all stuff that we've been showing that we can do here this week. They're developing the space within ICs to do this. So there's the working groups, and there's also opportunities to meet coming up soon. So there's the science conference, which is this year in the UK. There's a few theme sessions around EBM and food web models. They're still open if you'd like to attend. And there's this workshop, which I'd recommend you sign up to. And finally, there's some codes here to sign to if you want to learn more, but I should mention SEEK. So there's a strategic initiative for integration of early career scientists. If you are an early career scientist and you'd be interested in getting your model into IC's advice, scan this code or come talk to me. There's a great group that tells you how your work could inform ICs, and they support you as an early career researcher. So that's rapid. Sorry if I spoke too quickly, but thank you very much. Do you want questions or do you want lunch? I'm happy to.
Well, not burning, but I'm just curious, are there other ecosystem models also making the inroads in ICs? Because we need diversity.
Yeah, no, there definitely is. But Ecopath and Ecosim is making better headway than most, just because of how much it's everywhere. And a lot of our community is engaged, but we do have others. We have Osmos showing up a lot, Atlantis. Then you have a lot of the models of intermediate complexity. And they're often linked more closely to the stock assessments because they might require a few. Yeah, they're closer, less uncertain. Often we're viewed as strategic and not tactical, which we potentially are, but we're showing why strategic is also important. But yeah, there's a lot. We just want to make sure that, and there's a lot of work going on to ensemble modeling. So combining that stuff, Mike Spence at CFAS is doing some great stuff on that. So yeah, it's all happening within ICs.
Martha? Thank you. Great talk. Just a question from the Mediterranean perspective. You know that we are a bit outside the ICES. So we have been trying to participate, but there's never like yeah, a good fit, or we don't have funding. How do you see that? Do you think that there's new mechanisms that we could come as a third party, or
I'd imagine
save
so.
your career promoting?
I mean, ICES is a lot wider than the areas it gives advice for, and experts from everywhere are welcome to contribute. Whether that advice then feeds back to the Mediterranean, I'm not sure. And I guess that's a question for someone a little bit higher up the ladder than me. But I see it as being something important. We've got people that do come from all over the world and contribute to advice just based on their specific skills. So it doesn't have to be for your region. So I for example, I've got developed ecosystem models for a couple of regions, but I'm a member of working groups focused on, the Baltic Sea and things like that, which I have no idea about, but some methods that I've developed over the past is useful to that. So in terms of membership, more than welcome. In terms of advice, I'm not entirely sure.
Yeah, I think, if I may, I think your question was, how do you become a member? I mean, the advice is one thing as well, but just to respond to that, even the people from the UK that go to the ICES working groups aren't paid to go. I mean, if you work for the government pays for you to go. When I worked at SAMS, I had to find my own way to go. So I wasn't very much involved because I didn't have the money to go. And this will be the same for the people from the Mediterranean, right? Yeah. So I think there's definitely a lack of input into these working groups because of a funding situation. And I think that's something that we can really try and figure out how to fix. But yeah.
No, it is a big issue, and people at national level are chasing their decision makers to more formally put money aside for this, and it is working in some cases. We do have some government organizations that now have pots of money just for ICES, but whether that feeds down to academia is different. I mean, some PhD students, it's included in the funding statement that they'll get to go to ICES workshops and things like that. But also a lot of these groups they're virtual and hybrid, so you can have the opportunity to attend. It's often, these meetings, it's very nice to be in the room, but at least there is that option to attend if you don't have the funds to get there.
Okay. We have lunch. My stomach is growling. Thank you. I think we start again at 2:15, if I'm not mistaken, and Billy will be holding forth then. But remember, you have about another 7 minutes or possibly 10 to vote for the students, and then Kim will 7 minutes, and then Kim will close it. So thank you very much.
With the laptop. Really, it's gonna be really so laptop. This place is a bit. I don't know how long the cable is.
It might be possible, but from my side, I would feel more comfortable to just leave it. But
yeah, just wondering, how can we close it?
I'm not sure. I don't have enough technical know-how that I feel like just leave it.
Yeah,
I'm afraid if we close it at the Zoom, because the Zoom is from here.
It's from
started
here.
from here.
Yeah, but I was just wondering because Philly's laptop is like sticking a half out of it, so it would be.
Yeah.
We don't want it to drop.
Yeah. And we can try.
Oh, we can put it upright. Clap it open.
Yeah.
I don't know if it's. Oh, no.
I'm suggesting we put on the computer. I lost.
Okay. Yeah. If you have an Ethernet port for the internet cable. Yeah. Probably not. I know Mac. I don't have it. Then you can plug it in with the cable. If that works, I don't know. Okay. We'll put it on the computer then.
So it's the same. No, it's just if you don't mind, you say this. Okay, let's develop it. Now I have.
It's computed. Yes.
So one time that you didn't do it. Yeah, but I'm surprised.
Yesterday there was no problem.
Well, they're charging at the moment, so I can replace them after lunch probably. Or oh, the small one.
Ah,
This one?
I mean, they're working fine, so maybe I'll just.
I can check if they're charged. They're in charge.
That's the most important thing.
Thanks. They're also charging. We can check it.
Yeah,
Maybe I
is that charged?
If they're fully charged, then it's not. Yeah,
Yeah.
I don't know what.
Yeah, I think it's fine, because even if it fails, I can just come here, so I'll just.
Okay. Yeah, but
We put it to charge at the end of today.
maybe they're charged after lunch
Yeah.
already. So.
Yeah, thank you.
But I think it will be what will be within the workshop, not the. Normal. Yes. If the light is not on, the wood is not being recognized. Yeah. I know, yeah.
It's in ice cream now. I have lights. This true attempts was not really on this social. No, that's probably. Jesus Christ.
Maybe if you can, then.
I'm not sure, because I put only on there and did not on it.
Oh.
Yeah, there are other people, I know, it's. Because there was also another. Yeah, Biggs, I know his name, but no. He's, not gonna go, just added. Maybe he will complete something. ¿La de offshore o no? Ah. ¿Pero para cuándo es? Vale. ¿Pero lo quieren de anunciar ahora o...? Ok.
Mentioned that we actually brought out a policy document on offshore renewable energy last year. And so for the people who are working on offshore renewable energy, you might want to have a look at it. You can download it online, but you can also get a hard copy if you want. And there are policy documents about the environmental impact and what we need to understand offshore renewable energy. That's one thing. And then I think Simona has asked us, is that what we're going to see now? Yeah. Simona asked that we should put just the agenda for the workshop on sea lengths up. And who's gonna talk me through it?
1 second. Just it's an advertisement, of course, right? No, this is just to get the remaining agenda at the very last moment. So I want to share the fact that there will be the workshop on Friday regarding using Copernicus marine data for Ecopath and Ecosim. Will be hands-on computer from the morning to the afternoon. It will be these people, going with you through the data, what is available, what you can download, how you can transform the data useful for making them useful for Ecopath, Ecosim, and Ecosim. And there is an agenda. It will be all through GitHub that you will have to do. Okay. Yeah. Done.
That's it.
If you want more information, come to me.
Yeah, and yeah, that's probably the easiest. Yeah, I think other than that, I don't know if there's any other things that you are going to.
Also with this, but
Oh, yes, indeed. Sorry, I was like, what is that again? Yes, so there is also working group on also wind platforms. So again, this is probably useful for you guys. So if you are interested, I think some of you who only arrived today might not know about it, but they have put together a working group to look at offshore wind. So it's good to have people who are working on offshore wind to contribute to that. And with that, I think I will give it over to Billy. He's thank you. It's the Billy show, everybody.
I think you are very smart. Not being here on big mistake. Okay. What's next? Joe and I have been discussing it. So this is a joint presentation. Let's see if his leg stands. I have something to hold on to. But what I'm going to do here, because I'll be doing most of the talking since I have the talking stick, is to first give you a little bit of background and talk something about what happened at the previous conferences, just really like one slide about highlights. And then I'll talk more about where we are with the software. And then some ideas for how we move on from here. And some visions for the next big version, EWE 7. And we have more than an hour for this, 75 minutes according to the program, unless Sheila brings that beer bell up to stop us. But that also means that we don't need to rush through this. And what we can do, or what I intend to do with this, is really that we stop and have some discussions as we go along. But do remember that this sequence in it, that at the end we'll be talking about EWE 7 and how we are proposing to organize that. And that is something that concerns everyone who works with this. And we need involvement from a very large group in order to see that through. So that's what we'll be planning. So that discussion is hopefully going to be the majority of the time here.
Philly, maybe to chip in here. When we're having this discussion,
there's only one talking stick. How did he get one?
I'm a programmer. Anyway, what I wanted to say is, could somebody or some of you take some notes of what's being said? Because we are going to be nodding and very enthusiastic, but we'll forget half of what we're discussing here. Yeah? Is it going to be recorded? Oh, perfect. Nice. Okay,
no
then
problem.
I'll shut up.
No
The talking
problem.
stick is off.
We'll be fine. Okay, what's next? Well, we've turned 40. That's quite an accomplishment. And lots of things have happened over these 40 years. And where it started out with a simple tool that could do some neat little descriptive modeling, it has developed, thanks not the least to the person who you'll hear later this afternoon, who's going to give the World According to Carl presentation to close this conference. Thanks not the least to him and his very long experience in very long unequaled experience with modeling and introduction of the dynamic models. This framework has come a very long way over those 40 years. We celebrated it the first time when it became 25 years old. That was at UBC in Vancouver. And it was remarkable, even at that point, how many models that were being used or applied, developed, and how wide the use of it was, we thought at the time. So if you look at this survey here from that period, 325 models, you will also notice that ecosystem structure, which means mass balance model, and theoretical ecology, which also at that time meant it was more than half of all the applications. So a lot of the models that we saw 15 years ago were really quite basic, descriptive models that you still can learn a lot from. Well, I made my PhD on that, on comparing models and ecosystem maturity, but you can actually learn a lot from those models. So did Sheila. But it doesn't lead straight to policy and management. And back there in 2009, that wasn't really on the agenda. There were lots of models, but not really impact on management or policy, which had a lot to do with, even though we've been talking at that point about ecosystem-based management. I mean, when I started doing a master's and so on, it was with Danish Institute. So that was where Ursine had been, and Jydevaar and Ursine, Andersen and Ursine had been making the North Sea model. So it was so obvious back then that we were going to be doing ecosystem-based management. So I can assure you in the 90s, I was convinced that this was just, I could hold my breath and we would be there. It took a long time to realize that, no, there's a lot of things you have to have in order before that happens. So there was very little experience with ecosystem-based management at the time, 15 years ago. We have much more now. Lots of this was this focus on single species, and we've had to wait. I think, Howard, you talked about generations have to retire. There's been quite a bit of that here too, with the single species assessment and getting people in who actually is open to be talking about ecosystem effects. There's a lot of pressure for that now. That was not the case 15 years ago. It really is something that lots of people have helped push that envelope. At the time, one of the conclusions that was drawn in this summing up that I did at the end of the conference was there were many applications that were at this wanting stage. And I remember calling for us to grow up and be responsible and take on job and not just be playing as we've been doing a lot up to that point. And it was also quite clear that there was a lot of interest, 120 people coming to Vancouver for this. I mean, it's a nice place, but still 125 people is a lot. So this led to, the discussions there led to the following year, we established the Ecopath International Research and Development Consortium. I was at the World Food Congress. And then we took a breather. And suddenly, this is one nice thing about Ecopath. This is how we grow old, because we only celebrate every 5 years. So now we are 30 years old, and we are in Barcelona. That's where Marta and Jeroen hosted it. And the team there was modeling dynamic ecosystem beyond boundaries. The conclusions from that conference was, use of ecosystem-based fisheries management. That's the step before you get to ecosystem-based management, was still low. And it had a lot to do with modelers' lack of awareness on communication, awareness of what do the managers want, and communication with managers. There was something lacking there, but there was a lot of progress over those 5 years. The applications were really, lots of things have happened in those 5 years. So there was spatial planning, there were talk about ecosystem-based management, changing climate, and how we combine those things. Using EWE to communicate complex ecosystem impacts, was a lot of words. There was quite a bit about end-to-end modeling, and even some talk about cumulative ecosystem impacts. It was also quite clear that the toolbox had matured a lot and going beyond fisheries. That's where we started. But an ecosystem approach is much more than that. So lots of things were coming in at that conference. Marta summarized all of this, and these are actually the conclusions from her paper there. Well, there's also Ronaldo's nice water bottles, or bottles there with sand. That was a prize that year for, at least those who survived the trip here, with those bottles there with colored sand. Pretty neat stuff. This was also the Gaudi conference. Oh, Jeroen was busy with everything related to Gaudi. It was fun, yeah. But you can see here the 5 key aspects of that. One was the habitat foraging capacity model, which really has opened up much, much more than we were able to previously for getting environmental impact into the modeling. Of course, that includes climate change impact. There was the spatial temporal framework coming in as well. And that has been another, those two combined has really changed what we can do. Momentum to apply EWE for terrestrial systems. Did I really write that? But that was actually Sarah Fletcher that you heard in the previous session, who was the one pushing that part. So that made it into this overview. There were the additional formers as a kind of highlight too. And I would say from us as what Jeroen calls the mothership people, that's mixed blessing because there are so many nice things that can be done with these tools, but it doesn't help to move the mothership forward. So there's a lot of balance included in this, and I think we'll talk more, no, not directly about this, but it has been influencing our thinking about where we go with the next version. Yes, the rest, you read it already. So, hold your breath, another 5 years. We are now in St. Pete, Florida, making ecosystem-based model operational. And it was clear from this conference that EWE was used a lot as part of the management process. So that's what we're aiming for, by the way, being part of that process, being at the table, in the room where it happens. And that includes things like fisheries management, regulations, reference points and indicators. Reference points and indicators are really important because there's what Jason Link called many years ago called a messy picture. That's what you get out of it. You've seen a lot of these messy pictures. How do we make sense of those? Indicators are really important for that. How do we value food web effects? What can we do with spatial management? Environmental impact assessment, we've seen some examples of this, some pretty serious examples. And when you take the package there, this is actually really rewarding. No, remarkable is the word. I find it rewarding, but it is remarkable that we can do that with one tool. So by 2019, yes, there had been some clear progress towards both ecosystem-based fisheries management and ecosystem-based management. And we were clearly contributing. Well, that was 5 years ago. And if I can mention one thing that has happened in those 5 years, it's what happens in Europe. Actually, let me ask here. Here's a list of 15 Horizon projects. They're all big. How many of you here are or have been associated with those projects? Can we see a show of hands? Okay, it's like what I told my family when we went here. It's remarkable that there are, going by train, there are still houses in Belgium that doesn't have the roof covered with solar panels. I think actually there was a higher percentage here. But yeah, no, this is remarkable, isn't it? We were very fortunate actually to have the conference here. So this is fantastic. And what the European Union has done with these projects is incredible. And it's astonishing to see for these projects, there are 15 projects here that EWE is integrated into those. It's also an enormous responsibility for us as a community and especially for the developers here to, yeah. Do we supply what's needed? This is, this thing all really started with like 2 scientists starting doing some programming and getting things together, and somehow it has survived. I'll talk about why it has survived so long as well in just a few slides. But if we look at just where we are right now, I just made a few notes here. And I especially want to praise the diversity and the quality of what we've heard here. We've seen and heard so many good presentations. And what's upstairs is neat too. So thank you really for your contributions here. It has been a pleasure to see this. We have moved far with this, and that's become clear. We can see clear progress from what the status was 5 years ago to what we are now. 5 years ago, we were talking about making it operational. We have in so many cases now moved into that. And key to that has been this question of participatory research. that progress that has been on co-development of activities, and again, the EU projects has a big contribution there. But it's not just in the EU. This is becoming the norm in many other places as well. We've also heard it from the South Atlantic. It's the case also when we're looking at what we're doing, how we work in Canada. And this is really a trend, and it's a great trend because that's what's needed in order to get to ecosystem-based management. We need to have the social, the economic, and the policy and the mental aspects of that game covered. So this is actually remarkable. And I promised you that I would stop every so often, but that's something I have real difficulties with, stopping and letting other people talk. What I have left is I'm going to go into now to the software, but I think that's where we're actually going to have the most discussion. This is where we're going to have the discussions, really, really. But if there are any burning questions or any other things. No. Yeah, it's nice to sit down and digest after lunch. And okay, what's next? What's next is actually a little bit more background. Up to version 5, I think, it was this scientist spaghetti version that we were doing. And then we realized, no, we have to make a proper version. We need to get some damn programmers involved. And so we did that. We went to Lenfest and we got the first project that Lenfest Ocean Program funded. Can't remember what it was called, but what we told them was, we can actually make a version of this scientific software that is going to be used, that you can use for communicating what happens to the ocean. So in using it for policy matters. So we suggested to make some ocean summits with a nice gaming interface where you could see what comes out of ecosystem analysis. What do they tell us? And tell it in a language that is visual. That was the idea behind that $1 million project. $1 million was a big thing before we got the inflation from the EU projects coming in, but $1 million was for that. And of course, we told them that in order to do that, and in order to do it so it's scientifically credible, we need to redevelop the software. And so we did that, and we were pretty successful with that. See, what we did was that we see here on the right, we totally separate the spaghetti mix. We saw this noodle ball yesterday from, who was the noodle ball? I don't remember. But this was how it was before, a noodle ball. It got totally separated. So data separated from computational aspects and from the scientific interface. That was necessary in order for us to do this 3D gaming interface. Out, no, close the door, out. Christy, you're in trouble. So that redevelopment of EWE5 to the new EWE6 that was Jerome and Joe that was behind that, was really incredibly in the way it was structured. What we did with those visualizations was neat. Doing live, we connected a 3D gaming engine to EWE6 and used that as an interface. So we could, as you saw, things change over time. You saw things change over time, not on graphs, which we love, but which are not good for communication. But you could see it in 3D. That was pretty neat. And we saw that through. It's actually something that's still in progress. This here is the new version that's being developed right now by the same people, but 10, 15 years later. And it's part of Marine Plan. So actually these things there, that's a great way we find to communicate and change that. In the beginning we had things running over 50 years, and by the time you got to 1980, you'd forgotten 1960. This here is a great way of communicating change. So that was actually a really neat foundation that came to AWE 6. And in the software world, it is incredible that this version has survived now for 15 years or something like that. It is. A software that's not being maintained and developed is dead. It takes 1 year or 2 years or 3 years from you stop doing that until it's history. That's how it works. And we are at that stage now where we really have to think about what's next. So we knew this was coming. So back in last autumn, we started thinking about it. We got some advice from Leigh Gurney, who's not here, fortunately. But she suggested we should talk to a colleague called Greg Duggan from Cape Town. He's good at this. He's actually worked with Lynn Shannon before. He did a PhD down there with Astrid Yara, yeah. But he's now working and has been doing a lot of interesting work. And we basically got him on board as a consultant. And what we've done is to make the preparations for going out and asking for funding. So we developed a theory of change. That's now a buzzword for if you want to get a project through the World Bank or anywhere else, you need that theory of change. So if we fund you, what will that lead to? What will it change? And it's not that 3 people get a job, but it's really, from a societal point of view, what will it change? From an ecological point of view, what will this change? What will it do? So we defined that. We set up another few months' work on what's called a macro log frame that has indicators for this is what we're going to do. These are the indicators for it. We are working on a funding strategy in the pits. And thank you, Greg, because Greg can actually, we can't say these nice things, and this, he has that experience. So this is pretty neat. And we are also setting up now a website with a dashboard with indicators, pretty dynamic stuff. I'll show you some examples of this in the next. And where we are now is that we are getting these materials together. Literally, we've been every other week since the autumn meeting, and every time have homework for next time. So it's been a long process, but it really has been fundamental for us getting ready for going out and asking for funding.
It is basically that before Ecopath model needed to grow up, now the Ecopath ecosystem is growing up. That's basically the idea.
Here's some examples of what goes into it, and what will be on that Microsoft Power BI dashboard which is a pretty dynamic way and easy to update with new data coming in. Many of you have been asked about training courses, and we got a nice overview of that, and that's the kind of material that matters for when we go out for funding. We don't know who the funder is going to be, but impact and capacity building and wide reach globally are important factors. So we can show things like this. How many countries been on, what type of courses, who's been participating. We have quite a lot of information about this. We have about courses. Oh, there's a lot about courses because that's one place where we really got the data. We are adding to that now. Just show a pretty cute one here. You can go in there, you can say, what countries do you want for? Pick one, city, institute, course, participants, and so on. We have the consortium. We are now up to 34 members of it. And for those who don't know about the consortium, let me just say that this is not a legal entity. which also means that it doesn't hold money. So there's no charge in joining. If your institute is interested, talk to us or talk to the new board that will be elected on Monday or nominated on Monday, whatever it is. And this is open. The idea with this is research and development cooperation. That's what a consortium is all about. For the dashboard, we're working on a lot of other things, a lot of additional indicators to go in. And a very important one is policy impact. We have been talking to Overton, the company that is behind the big database that exists about this. If you don't know about the SAGE policy, what's it called? SAGE policy profiles, then look it up, because if you have your ORCID ID, you can go into SAGE policy and you can see the papers that you've been involved in. How have they been cited for policy and management? You can find out who cited it and in what publication and so on. So that's a really nice resource. We're developing this for all EWE publications. And to that extent, EII has set up to get a database. Many of you know the one I have been, the collection I have of PDFs with, I don't know how many, 800 or something like that over the years. We've expanded on that one now and have Jerona and a colleague has been working quite a lot on that. So that's going to be the foundation for it. That collection of papers is going to be really neat to show what has happened. And this is important for fundraising, not just for the big project here, but it will also be when you go out for fundraising to have that kind of information available.
Can I?
I don't know if you can. You can try.
I could try. Let me try. No. So indeed, we've been working to complement the database of all the publications, government reports, thesis, whatever document is using Ecopath. We've been putting that in an indexed Zotero database, and we have the PDFs that we want to scrape with Chat PDF to extract these kind of statistics that we also showed for the courses, just to show what have models been applied for, what purpose by whom, and etc. But we need your help for that as well, because we're also finding papers in Chinese, in Indonesian languages, in Spanish languages. We find them in Japanese. What we want to do is put this database on the EI website, just have the master list of publications. But if you see something's missing, we need your help, right? Because so if you have something, if you know that something has been pushed out, send it to us. We need people to also help us with the non-English languages, because there's tons of stuff being done that we normally don't stumble across. So if you're interested in helping there, we'll find a way to make that to throw a poll out, but we really need to get you involved in this.
And we will make this database available in the foreseeable future, yeah.
And we'll do it in a way that from the EI website, you have, if you have something like Google Scholar or Zotero running in your website, you can add your citation straight to your documents. I mean, we want to make it as easy as possible. Kim, go ahead.
Yeah, I was going to ask, do you want to add gray literature as well? Because that would be hard to find. And there's
definitely.
reports with Ecopath.
Absolutely.
Yeah.
And we have quite a bit already. We have some of the reports even that you wrote. They're in there. And master's thesis, government reports. There's tons of material. So anything you can get your hands on that relevant. If we don't have it yet, add it. So we may also want to make it easy for you to see what we have and what we don't have yet.
I think we have about 1,200 publications now.
Yeah, approaching 1,300 now.
Yeah, which is also pretty impressive. Okay, that's it, almost. So we've been thinking about EWE 7. How do we get there? And we have to get there, because EWE 6, while it's been great, while it's been great. There are so many things happening now, so many new tools, and we have to rethink them. So
well, basically, we re-engineered the software almost 20 years ago, and it has given us 2 decades of life, but the world of computing has changed so dramatically. We have AI, we have cloud computing, we have all these other things that we should embrace. So we need to do another lobotomy, and this is a list of features that we want to embrace.
And the obvious annoying things is like Windows. which as a faculty is really a problem, because you come to a class and you see they're all using Macs. Okay. In my world, yeah, I've had that happening for my courses. Yeah, everyone Mac. It's not always, but it happened last time, I think. So OS independent and online, that's one of the things that's quite clear there. It's also clear that there will be a current version of the scientific software, much like the one we have now, just a bit smarter. I mean, we can ask for help from this PDF chat and for information there when you're starting to build a model. So there can be a little bit with that for help for getting the right papers and how to get the information out. Another thing is, we've emphasized capacity building throughout, and there is some lack of democracy involved, in the sense that if you are at an academic institution in North America, in Canada, we have free access to supercomputers, and we use them for this. This is why Greg was able to do. No, this is not why, but this was a necessary tool for Greg to get to where he was. It was a necessary tool because I wouldn't be able to get there, but he did it. But that's the kind of things that's not very democratic. So one of the things we're talking about is, as part of this new project, setting up online computing facilities that you can work with for heavy-duty computing, which is something that happens more and more. So as soon as we're talking spatial model, temporal spatial framework, you don't want your notebook to do anything else if that's what you're running it on for the next couple of days, maybe. So setting something up like this is something that's really high on our wanting to do list. And there is the experience for it. But so it's feasible, and we would like to see that happening, that there will be a way of doing that. We hate the database that we have. This thing about updating it, and you can't use the old. You should hear Carl talk about this. Oh, I wouldn't want to be. Jerome shouldn't be around when Carl talks about this. I mean, temporal spatial framework, yes, it absolutely has to be integrated. We've been hesitant with that for two reasons. One, we have no funding, but as important is, it had to mature a bit before we could find out how to really work with it. The way I work, I had it quite easy, because when I had to work with a temporal spatial framework, I just got Jerome to do it. And many have been in that situation, because but it's actually working really well. So it's time to get that into a new version and give some good guidance on how you can use it. Now, as we are thinking about this new activity, it's also become quite clear that the model for it is like the 15 projects you saw in the horizon. We're talking about a project with many partners run by a consortium. Could be the Ecopath Research, International Research and Development Consortium. I mean, that's the first place we will look for partners for it. That's quite clear. It has to be run by a consortium, because it's no longer a question of how Carl Walters and I think that this software should look. That's history. We need to do that. And in order to do that, that co-development, that development with all the partners, the co-development comes in here again. This is really, really important. We've heard so many good examples of that in the last 3 days, and that's where we're moving. It also becomes clear then that when we're talking about something like this, we're not talking about $1 million as we used for the last. There has to be many more people involved, has been many institutions involved. We have to work with stakeholders and industry. That can be the same, but and people. Basically, it has to be a co-developed activity. So, last slide. Almost. Well, I'm going to be talking a little bit about at the end about conferences, but that's not much about that. This here is really the last real slide. So these are kind of work packages that we've been talking about. And you'll notice that there's a little separation there after the scientific version. The idea is that underneath the all, like one rings that rules them all, is the scientific version. The difference between Ecopath 6 and Ecopath 7 is that you're the only ones who should see the scientific version. And that's where you develop the model. And once you have your model and so on, when you start working on it for the project, and you go and you talk to people about it, you work with something that is tailored specifically for that purpose. That's discussion that we had. Howard, you remember we had that discussion 5 years ago about fisheries management. What do you need when you go to a council? And we told Noah, if you fund this, we'll do it. That discussion is still ongoing. Well, there was a little pandemic in between, and a few other things. Okay, so there's this list here. I mentioned the fisheries management. What do you need there? What do you need when you go and you work with the South Atlantic States Fisheries Commission, or what are they called? What do you need, Dave? That's what has to go in there. But you would be nice if you did that so that the colleague who works with the same, with STCF, also can use that, or we have slightly different one. So the idea is, what data do you need? What's the data flow that's involved in this? What interface do you need for it? How will you present the results? You want to be able to play what-if scenarios? Absolutely. All of these should be able to do that. So you want something where you can go in and you can pull something and see what happens. So that's the idea. That's what we like to see. You don't have a talking stick. You have to have one, because this last session you were talking without one.
I was wondering if I can ask questions. It wasn't clear to me.
This is it. So
Okay.
Now it's
So I will start the discussion then. And specifically on data, actually, I think we really need to be the discussion we had earlier with ICES versus the Mediterranean. I mean, that's just Europe, and we already have, parts of Europe that don't do things the same way. I think if we want to do this well, we have to find a way to really make the data ingestion part of it easier. And I think we should really speak to Emotnet, because they've been doing that very well to get people to ingest their data. So we really need to try to learn from them, to try and figure out how are they doing it? How can we work with that? And so we kind of need to have a way to make sure that it isn't very one system specific, I think. And I don't really know how to do it, but I think that is something that we really need to. It will make it a much more useful tool if we make that step easier, I think.
The data flow.
Another thing is that if we want this to actually impact policy around the world, we have multiple language in the outputs. So like the indicators and everything that we're presenting, if you're doing it in South America, it should be in Spanish or Portuguese. If you're doing it in Africa, it should be in whatever language we're speaking, in Arabic and French. So like we need to expand our single language output beyond English for sure.
The word for that in our terminology is localization. And when we developed Ecopath 6, we discussed this quite a bit. And we arranged it so, that was the programmers. I'm not supposed to say this. No bullying allowed.
Not today.
No. We, that's not the royal we, made it so we could localize it. Which basically means everything that you see on the screen is a label that you can look up in a table, and then you can make a Spanish list, as we talked about many times, Santiago, and you can make one in different languages. And for some strange reasons, we have never got the funding to actually implement that. We may not have been looking hard enough. We talked to a number of people about it. There's been colleagues who said, oh, I can do that, but it has never materialized. So Santiago, yes, absolutely, you're right. And there is a straightforward way of doing that through localization. So that's clear enough, yeah.
One of the limitations here is, of course, academic funding, right? For academic funding, you can only do new marine sciences. You cannot translate the software. That is not, you can't fund. So that has always been the issue why we're having these discussions over and over again. That's why we established a consortium. That's why we try to find other ways to survive. And we've managed now, without core funding, for almost 14 years.
But like maybe the software can remain in English, or like the scientific interface, but if you're presenting. Sorry, but like maybe the software can remain in English, but the interface that goes to stakeholders, like if you're in Thailand, it should be in Thai. It's just like straightforward.
We will just make one version, but we will make it so that it's with these tables where the software looks up that number 16 is what goes in here. So it's a question of changing that, but that's the kind of things that would call for local adaptation. Yeah, we really think it's really important. Yeah, totally agree.
But the same issue is also when we've been developing things, it always happens on a shoestring budget, right? The budget is limited and they ask for the moon. So there is also never funding to update the help text, which led to this, well, something else Willie will talk about soon. So yeah, it's always a bit, we have to make trade-offs, and that's very unfortunate. So I think in that sense, also as a software approach, you need to mature and include this when we budget for new software development. Yes, that means you can do a bit less, but you pay for other things that are also necessary. So that's on us.
Yeah, I want to ask for clarification about when you say data, what does that word mean? Do you mean model input, or that's really the data you use to derive model input? I think a lot of times modelers come to us telling us they don't have enough data to populate this model, and we give them data. They still cannot do the model. Yeah, so I think you probably saying the inputs or data.
Yeah, that's a big question. You're right, actually, because indeed, any data that we're going to get, if you get stock assessment data or if you get something, is not going to be precisely in the format that needs to go into the model, right? So there is probably some sort of conversion that needs to happen between whatever data we get, whatever data is available, and how do we make it into the format that goes into the model. So it is probably a step or a few steps in between that I haven't thought about. But I think we really need to be aware that it's not just getting data from EMODNet or from CMIMS. I mean, there's a whole workshop about that on Friday. So there is some steps, and some of that can be probably automated or something. So, but we need to think about that process, I think.
Yeah, automated data curation is quite difficult. I mean, if data is expressed in the wrong units, the wrong entities, at the wrong scales, I mean, anyway, you can do some of it indeed automatically. Sorry, okay, you can go ahead.
I just want to clarify, we're asking for discussion and feedback at this point now, right? A suggestion that I think I'd make that's been apparent over this conference is maybe a push for shared coding workflows, open coding like GitHub that Jeroen had mentioned. Like, had a couple conversations with people that have different scripts for processing ecospace outputs with Igor and Greg, for instance. And for instance, we have scripts for running parallel processing with the console in R. I think some dedicated effort to try to bring this together would help lighten the load on the programmers, because we don't need Ecopath programmers. A lot of these would be in the languages that scientists are using, like R and Python. And so some of that would take resources, but I think building up some of that, I think could really help lighten some load of not necessarily having to program this into EWE7, that we can do it outside of EWE7. I'd like to hear Jeroen's feedback.
Well, it's also what, for instance, what we do when people come in with scientific ideas to have something programmed. There's the consortium. There's a series of experts here that can check whether something is a viable idea or it's plain dumb, right? This could also be done that we know that there's thousands of scripts for analyzing Monte Carlo results, for plotting things, for comparing things, etc. And we are planning to put those in a structured GitHub repository where you can all add to. And I think it's still a valid idea that you may have a programmer to audit what you've done to make sure the script is really generic enough. There's no hard-coded things in there. There's no nasty paths. There's no assumptions regarding group indexes. Everything is clean and reusable. And we can help with that because we've got that experience. So I think, but yeah, the more you can offload, the better, actually.
One thing I forgot to mention was how we see this thing being developed with regards to the programming aspects. The idea is that for each of these work packages, there is a programmer and a scientist that kind of is in charge of that. A scientist that's in charge of that work package and the programmer. Those programmers, we don't want them to sit at EII. We would much rather that certainly the key institutions that are involved in this have a programmer sitting, working with this. Those programmers can work together. And part of that is, well, it's a lot of packages we're talking about. There's a lot of topics, but there's a lot of synergy between them. So that will help a lot. But it's also a project that may be running for, say, 4 years. And hopefully, when those 4 years are up, the value of having a programmer in your group that knows how things work and can work with that will be so big that for new projects, they'll be written in. So we would really like to see that it's not, there may still be a little core group, but that core group is working with developers and programmers in the various institutions.
There's a question here.
Question number 2.
Oh, okay, thank you. Just one quick observation and one question. And I'm thinking, because I'm glad to see thousands of applications for using Ecopath, EcoSim, and for different water body. And one observation to me seems like this model, this software is very easy to get hands-on, which is great. And but for all those people who working using this model, they can also make their own model from imagination. So the things is probably people can make that out of the using outdated data, and they using the information is very limited in the local area. They can put together, balance the model, and make the model work. But actually, if you look at that output, look at those the time series, they are totally from if the people who work in this with the system, you will realize this is definitely is not the model for that system, but they call this model as a system. And that I think that for most people who are working in that system, they may not know how EWE works. So they may say, okay, this is because of the EWE model estimate wrong. They are not attribute to the data input, and they are using wrong information. They output the wrong results, but they published. So that's the part of things I want to bring other people attention. That's really ruined EWE's reputation sometimes. So we have to be careful on that. Right? So data has to be very, very at least close to reality. And you have to know the system and very well, and then you can work on that. So this is just my observation. And the question is here, sorry. Is you mentioned the scientific version and public communication version. So I'm just wondering, maybe my understanding is wrong. So what is the difference between those two versions? I'm thinking scientific version is great. So the people who try to convene those results and bring those results to the public, to the people who work in the system, that's the key. The purchase is the key to make a communication between those groups.
If I may remember something, which reflect on something, it would be some years ago, like 10 years ago, 15 years ago, there was some bad reputation coming from people, individuals making models and drawing non-supported conclusions based on such models. But what we see now is much more co-developed activities, really data rich, that where the questions and the interpretations are done in wide consultation. So it's a totally new scene we're talking about. And that's what this is aimed at. Now, the version down there that's called public communication versions, it's not just because all EU projects, if it should be such one, needs to have public communications in them, but it's actually because there is so much you can learn from these models and you can play with them. So we're thinking of having as in that one, and this is, that much thinking. The work package group will have to make it that much, but it would be something you can bring to a high school or an elementary school or to a group of managers somewhere or put on the internet, but something where you can go in and you can get a sense of how this ecosystem works. What happens if you put a marine protected area? What happens if you increase this kind of fishing and so on? So something along those lines in a simple, relatively simple presentation. That's the idea with having that one there. The other packages here needs to have something similar, but it's something similar that may be targeted for, should be targeted for the target audience, not for general consumption, so more specialized.
If I may add to that, for instance, remember the talk we just had by Sarah Freitzer, looking for an ecosystem model that runs in wind park planning environment. That uses the same engine, but looks and works very differently, is catered to the workflow of somebody else, right? That is, we wrote a very cool paper with Sheila about the challenges for the ocean decade, in 2021. And this is one of those models, one of those papers that describe that ecosystem models have such a societal function. You can put them in another environment where they can provide ecological feedback to whatever you happen to be doing. It doesn't have to be ivory tower, desktop, scientific software, right? Try to bring that across. So it is thinking about those kind of lines, like what we did with the MSP challenge. Unfortunately, the game that didn't make it here because people didn't know about it, I think. But it's a serious game where you plan maritime spatial plans and you get ecological feedback to what you're doing. It's a scientific model that runs way out of control of all the nervous scientists, right? It runs by itself and it just responds to spatial planning. Our models, if you rethink how you can use it, there's so many opportunities. So that's what we're trying to think of here. And in that, have people working on that, but also work on the mothership, to build more redundancy in the development team, be able to have more brains behind it so we can quicker respond to new ideas. Because now, of course, yeah, it's just me and Joe, basically. So development isn't always very fast. Because we're busy with other things. So
we would, just adding on, we would like that, so the groups working with this, they may well decide we want to make a version that's slightly different and has these and these things, so we may get different versions. That's we're kind of saying that doesn't need to be, there probably still needs to be one scientific versions, but it can have a lot of things being added in. We don't even know the right version of programming this yet, but that's of less concern. the thing is really, we want it to be open for much wider development group of developers involved in it. That has to be a key for this to still be around for Ecopath 50.
Yeah, thanks, Vili. And thanks, Jeroen. So, Vili, I was sitting here absorbing what you were saying, and we were listening to the YouTube when we walked in late. We walked in late. We were listening to you, I promise. So don't worry. YouTube was giving us a gift. Anyway, sorry about that. Anyway, so I was thinking about hearing you say, we need programmers for all of these work packages. And so my first reaction was like, well, how am I going to pay? How am I going to pay for these programmers? But then I just kind of stepped back for just a moment. And at every grant I write, there's always a line item for the consortium or EII where I can ask Joe or Jeroen for help for whatever I need to do. Okay. So if I just kind of flip that on its head and move that line item up to a programmer and put more money into that line. So then maybe for 2 to 5 years, I can fund a programmer. Now, where do I get that programmer? I'm in academia. There's probably someone there, but there's a huge resource, which I just thought of just now, that the entire globe has at its fingertips. And I don't know internationally if you all have Fiverr or Upwork or all these places where you can outsource the programmers. But if we all did that, and if we all looked for one, we could probably find someone that could consistently do this. And so I wanted to say that maybe we need to think about this differently, but why I stay up late at night is because what if Joe or Jeroen can't do this anymore?
Yes.
And that's what drives me bonkers.
And we are aware of that. Absolutely. And what you are talking about there, that's how we want to make it sustainable beyond the bigger projects. For the big projects, you're not going to give us 10 million. But we are hopeful that someone will. Now, it may, in the ideal world, next month, there is a call for digital twin tools where we can go in and ask for 10 million and come with that ballast of having 15 existing Horizon projects that are using the tool. That's a possibility. When we started this development with Greg Duggan, the assumption were we're going to go to a foundation, Packard, Betty Moore, one of those. And again, what the advice we were getting was, don't ask for 1 million. They're beginning to get interested if you ask for 10. And at the time, I think we were thinking, that's a lot. When I see the vision for it now, I would say, yeah, 10 million plus. So we need something along those lines. We don't know where that will be. I have written here industry as well. That might be another possibility. I'm not talking about the standard fishing industry, but it could be a big company that was really interested in green energy and that kind of things that would say, well, if we can have a license for this thing here, you can do the other public and so on. Who knows? But we need it. Howard is probably going to give us 10 million. No, he's not. But one challenge would be if this really ends up being, say, a digital twin call that will fund that, well, that would be great for a majority of the people here. But there are many cases where, certainly in Canada, where Canada has teamed up with those. US is kind of the poor twin right now, or poor cousin compared to earlier times. But there are openings there as well. So it might well be that we say, well, maybe one of these work packages would actually be something NOAA would like to see happening and can find ways of doing it when they know that it's part of a consortium. So that's, we need to get there. That's what I think is important. And then I think doors will open. Howard, okay.
Yeah, hi, Willie. I would like to link on this intervention and also to Holden's what he said. I'm quite in agreement that actually the standardization and the organization, the logistics of data should be also kind of a priority, because I think that going through Ecopath through the different schools, that's been quite streamlined, but there's a quite steep curve in getting the data inside and getting them outside in different formats. So I would see that developing the 7th version it's two things. One is the code itself, the Ecopath, but the other is all the supporting software. So the ingestion software and the production software of different formats, visualization, and so on. So for example, what Simone didn't have the time to show you, but when we were building the Adriatic model in the first sea, we had spent months just processing different data. So one of the important thing for me in my limited experience is that I think that the formats should be kind of standardized. I don't think so that we maybe can influence how the data are provided to us, or that there will be in a uniform format, for example, for fishery data or for survey data. But if we kind of in each own region creates kind of a tool that converts that data to a standardized format, then one single code could process that survey data and ingest them directly to Ecopath. So instead of everybody of us losing time and money to create those translation codes, just one could do it. So I think it's very important that we streamline the before and the after, not just the in between.
Thank you, Igor. And yes, I agree. And if you can think of this a little bit like what's up there, that's in. And what's down here, that's processing and out. That's where we produce things, and that's how things get out. But that part up there, yes, a lot more can be done. And it may well be that we have different modules for treating different forms of data and so on. But as a group working together on this, on a big project, hopefully not just on one continent, we have those, the doors will be open, that there are possibilities for that. And it's important, yes.
Okay, I will take this to totally development perspective technically. To make it more sustainable and feasible, we need to spread this development or coding, whatever, to the base. But Ecopath with Ecosystem is a very sophisticated software suite. And at the moment, what I see that it's not possible. Because UCAR has done this. UCAR has an NCAR command language in Fortran. And they had a very core developer group. And then they switched to Python and Python native libraries. And it was, well, we can debate if it's how to what extent it was successful, but it's a much simpler software. No graphical user interface, no gaming engine that we would like to capitalize on. So it was more straightforward. We just moved from one aspect to using something else. But in Ecopath with Ecosystem, it's not possible to do it because we have very nice this gaming engine that you have shown us, that dynamically converting scenarios. So it would be possible if we could do this, but there's a very steep learning curve to contribute to the software. So the only way forward I see, to my opinion, either two ways, and translating this to something another languages will be almost equal to killing Ecopath with Ecosystem, because let's say making it another, not Visual Basic but C#, I don't know. But to my understanding, we need to recruit. You mentioned the two options: to become a foundation, like Software Ecopath International Foundation or something like that, to get money to sustain the development with a larger user base, because it needs expertise. It's not like open source projects that I can just go and fix and submit a patch to GitHub, or getting a project for the next version of Ecopath with Ecosystem, 10 million project or a few millions of project. And I think these are the two ways that, in my opinion, will carry Ecopath with Ecosystem for the next century or so. Otherwise, it's really difficult to translate this to something that everybody can contribute, for instance, R or Python, because our software is very sophisticated and the user interface is very important. That enabled the high adoption of the software, plus this nice visualizations are a must. So if we move to Python, for instance, we would lose maybe many of these goodies and niceties.
Yeah, of course, you're right. I mean, we opted for .NET because .NET is one of the most versatile and mature application development platforms. It's not purely data. In .NET, you can do everything, but yeah, if you want to contribute, you have to know .NET or something that's not .NET compatible. We will never satisfy all the user cases, but I think we should consider this when we start talking about this for real. I mean, it's not that we have to decide right now, right? But I think the idea is noted. There is, for instance, a new plugin system, the web plugins that are basically language agnostic that now browsers have adopted. So that would be a way to restructure the plugin system. Then let the code be in .NET, all the user interface, all the smart bits, but you can interface with it from any environment to add your own plugins or do your own scripting. So I think the computing world has changed so much that we can solve these problems. For me, they're now actually just details, important details, but how are we going to do it? I think we come up with something good. I'm not so worried about that part. It's more important to identify the bottlenecks and put those on the table and make sure they're absolutely clear. I mean, I think that's the first step, right? So map out what we want to change, what we need to change, what we need to update, what has worked and what hasn't. And I think if we do that really well, we can give the software another 2 decades. And that's pretty cool, no?
Thank you, Egan. We are very much aware of this issue.
5 minutes.
What? 5 minutes? Oh, okay. No.
Jacob, because I took the microphone from Jacob to give it to
All right. So just a couple things here. No, it's don't have $10 million to give right away, but I think I can, over a few years working with y'all, loosen up some funds somewhere. So we'll talk about that at the Ecopath Consortium meeting. But kind of to address Christy's concern is also a concern with me. I'm noticing all the NOAA folks who are using Ecopath, and yeah, what happens if Jerome wins the lottery and moves to Fiji and says, forget all this? So as I like to do, I like to ask people to raise their hands. How many people here represent some sort of government agency? What if each government agency had a programmer to contribute 30% of their time to learn an EWE? And now we've got diverse group of people who all know the core backbone of scientific version, right? So if something happens, one of those people move to Fiji, we still got, 15 other people that spend 30% of their time on this. 30, I just chose a number, 30%, 20%, some percentage like that. We have like some sort of training for those folks. All right, now you all know the backbone algorithms in the core, and you can help with that and make sure we keep that advanced while you all focus on the academic funding, and us, we can help with that too, for advancing these other work packages. The programmer consortium, yeah, that's a good idea. That's a good. Now, who do I give this to? Okay. That's what I have the last word.
I want just to link what Howard was saying and you were saying, Christy, because it's we need to clone Joe and Jeroen. That is the fact, right? So even if in a miracle I win the lottery and decide to invest that in a 10 million to train someone, we need more than one, and we have only 2 teachers. Maybe 3, really? Carl, if he wants to do it. So, it's how many? So we need to also optimize that because, for instance, if we have a consortium of programmers, then, one, you can train 4 people, 5 people, rather than, any institute is calling you, I got the million to train someone, and then you have to run to train everyone.
Okay.
Yeah, exactly. So we need to optimize the process of having more.
We got it. Jakob.
But the idea to have your in-house geek to help you with your scientific processes, but also work a bit on Ecopath. Some teams have discovered the bones of that you have with Joe and Dave, and I do that with Marta's team. And I think it is so beneficial if you have somebody to supercharge your own processes, but also contribute to the overarching approach. I mean, that's what we're to aim for, of course.
Jakob, we're not done yet.
Oh, Jacob, last words.
Sheila, you take the little bell and you go outside with it.
There's another question here too after.
Hi, Billy.
Hello.
I think I was first, but go ahead.
Are you going to sing a duet?
Sorry.
Please.
No, I just wanted to talk about the communication version of this, and I was wondering, is this like a list that would be set in stone? So at the end of it, you'd have all these different versions, or is it the idea that you'd have a scientific version, then the communication version that we can have control over what that looks like and augment it? Because I mean, if we have like a fisheries management interface, like Santiago is saying, this is going to be different for every community you engage with. They'll want to see a different interface, and even better, we'd want to co-develop interfaces with them. And like we were talking earlier about policy as well, and how quickly they're asking us to pivot what we're using to models to look at. So, you know, I was just wondering.
Okay, something that it should be clear. It's going to continue to be an open source free software. It's going to continue to have an interface that makes it easily accessible. This has been fundamental for us getting where we are now. There's going to continue to be a scientific software where the scientists can do the data manipulation and analysis. And then we're suggesting that for when you go and you work with people, you have a different interface that can be modified. So yes, you want it different than the fisheries councils, but that's very different from having to develop it if you have to modify it. Sorry?
Putting a different wrapping on the same stuff.
Yeah, some modifications. This is how this is going to be is very much up to the work packages and the consortium working with them, because there has to be a lot of unity across these, but different looks.
But
A lot of us are doing a lot of this thing.
But we'll see how we make it all work. But I just think Lego, colorful blocks, you put cool things together. That's the analogy. And what we're exactly going to do in the what work package. But the idea is to have multiple people working on that and be able to have diversify also where we put our engines and how we use it. And how it's all going to play out. Well, we'll have the theory of change and the indicators to find the funding with. And that, if we keep that up as a community, we have something very cool, a good currency. We have a track record that's ridiculous. That's great. So with that, we should be able to get something.
I know we've been jumping around a lot, but I just want to jump back to the like data standardization idea, because somebody who uses entirely non-traditional data sources, I'm hesitant to encourage only like a way to standardize data before putting it in, because one of my data sources is like the salmon was so abundant you could have walked across the backs of the salmon to get across the stream. How is a computer program supposed to standardize that to get to biomass? Like there's not, like you can't necessarily have all of your data be able to be standardized. You need a human behind that, and we do collaborative data generating meetings to get to this information. But I think we also, to make sure this stays relevant and adaptable, standardization isn't necessarily the way to go for data. Like we need to be able to be creative and artistic when we're creating the biomass data, when we're adding all this stuff in, because otherwise we're ignoring 99% of the available data out there. And that's, as somebody who doesn't use traditional data sources for Ecopath, like I feel like a bit of an outsider here, but like I think it's limiting us if we're only using that. And if we're only using the stuff that gets us to tons per kilometer square per year really quickly. This stuff doesn't happen quickly. Artistic science doesn't happen quickly. And sometimes we have deadlines, and that makes sense. But sometimes this stuff just takes time, and that's a good thing.
Thank you. I hear Sheila. Oh,
I'll be really quick.
thank you. That was quick.
Yeah. I think it's just worth saying, while there's, you know, the broad group here, the diverse group of users, that I don't think we're already doing it, but just periodic deep dives into the user base to kind of understand the attributes, dimensions of our, you know, market niche. Like there's
there's reasons why the software is very popular, but you know, what proportion of the users are people that like to script? How many prefer the point and click? You know, all these different dimensions of the user base. It would be great to have to see that and how it's changed over time, and use it in future pitches and things like that.
Thank you. And I'm going to take the last minute. So what happens if EWE is not funded? Well, if it is, then we are committed to see that through. But it is really now that succession has to be planned. And the part about it being so that we have developers and programmers in key institutions is a fundamental way for survival if we don't get the big ones. It's also a key fundamental one if we get the big ones to go beyond it. But that's it makes it much more simple if we get the big project first, because then it's maintenance we're talking about. For that project, it's also development. So that aspect is really, really important. And I put there, so long and thanks for all the fish. And if you don't know it, if you don't know Douglas Adams and the Hitchhiker's Guide to the Universe, you don't know much. This, so long and thanks for all the fish, that's the 4th volume in the trilogy. And it's, yeah, that's what the dolphins said when they left from Earth to go to another planet. And go to another planet, there's also going to be another conference where I put a black box there for number 5. And that's because I'm not going to be involved in development of it. Now we need succession here. So there's been a lot of interest. I think it's great that we have them every 5 years. It's so nice to get to them. I love to do that, continue doing that. But we need to talk about this. And this is going to be a topic for the consortium meeting on Saturday. It's Saturday afternoon. Consortium members are strongly encouraged to send someone there, as we all know. And it's an open activity, I think, in here. Yeah, so if anybody wants to join it, who should still be in town, you're welcome. Just go online and make sure that, or send an email that we know you're coming. Send an email to the EMB. Yeah. And thank you.
Thank you. I will say that the reason I'm chopping you is because Carl is getting up early to give us the keynote, and I don't think we want to, you know, be late for that. But also, we still have an evening reception after Carl's talk, so we can still continue these conversations. I think this was the beginning of that conversation. It's going to take a long time. Sorry? Yeah, it's on the program. There's drinks afterwards, so we can still talk afterwards for those of you who are still here. Yes, really. And a few small things. For the workshops tomorrow morning, they start at 8. The data lakes one, I think, started at 9, but the other one started at 8. So yeah, be aware. And I think there was something else I was going to say on the workshops, but I can't remember what that is. Oh, yes. And the people who are actually the trainers of the workshops, you cannot have a beer until we've told you how the other rooms work. So please meet here before at the end of the workshop, at the end of the conference, so that we can go and show you the rooms and show you how it works. So that's it. Let's have a quick coffee before Carl arrives. Yeah. You can do what you like. To sign? I mean, yeah. When they're there on the day, yeah, on the day I will just. Thank you. I knew there was something else I needed to say.
That's fine. For the teachers, we're also walking around probably tomorrow.
Yeah, but I think
I'm gonna try to sneak in some courses.
Hello. Hello.
Hello, can you hear me?
Yeah, really, really well. Because
Great,
we, of course,
okay.
we're in a meeting room. Yeah, maybe you can test your share screening, and yeah, of course, good morning to you and thank you for joining.
Good morning to you. You're Angel, I assume.
Yes, I am. Yeah.
Okay, good. All right, so I'll
Yeah.
let me see here. So you have a share screen option on.
Oh, sorry. Yes.
Okay.
Probably, yeah.
I'm going to try just sharing this PowerPoint presentation. Okay. So,
Yeah, we see it really well.
so you see the PowerPoint presentation.
Indeed. Just let
Okay.
me get thing ready. Yeah. Yeah, we see it well.
So that's all you need from me right now. Hey, so what I'll do is, should I just leave this up on the screen?
Yeah, you can do that. Yes, the only thing that we will do before your presentation is to give the award to the best oral presentation and poster. So if you are sharing your screen, you won't be able to see who are the winners, but you will hear who are the
Well,
winners.
I would prefer not to come on until you want me to be there. Okay, well, okay, I guess I can, I mean, I'm not gonna sit here and listen to stuff. I'm not feeling very well.
Oh, okay.
So, I'll be back at 7:15, okay?
Yep, sounds perfect. And yeah, hopefully you will feel better in half an
Yeah.
hour.
Oh, okay. So will my presentation be appearing on your screen now?
Yeah, so your presentation is in our
Okay,
screen.
so
Yeah.
let me see if I can stop sharing
Okay.
for the time being here. So I'm not sharing my screen with you. And let me see if I can start it again, okay?
Yeah.
So now you're seeing it's not in presentation mode.
Yeah.
Okay, and this puts it in presentation mode.
Indeed, it does. So we see
Okay.
it really well.
Okay, so I'm going to stop sharing now until you tell me to start my talk.
Okay. Would you be able to somehow hear us, or should I send you an email in case, for instance, we have some delay or we start earlier?
I can hear you.
Okay. All right.
Oh, actually, I can't hear you. I'm on the headphones, but I'll
Yeah.
check back in about 10 after 7.
Okay, that's
Or 10
excellent.
after. Okay.
Perfect.
All right.
Thank you
I
very
just need to
much.
do a few other things
Yeah.
while I'm waiting here. Okay.
Thank you very much.
Okay.
See you in a bit.
See you in a minute.
It's headset, but well, here's the camera, so I don't know.
Hey, Carl.
Hey, Dave. How are you?
I'm good. How are you? I just came in to get my water bottle, but now I get to have a personal conversation with you.
Yeah, not for very long here. I'm not feeling very well. I've got a pretty awful sickness, and so I'm just gonna come on long enough to say hello for a few minutes to people and stuff. You're looking well.
I'm having a good time here.
Yeah.
Good to see you. I'm sorry to hear you're not feeling well.
Yeah, no, I got some kind of terrible autoimmune disease that I'm taking all kinds of drugs for it, but it's completely screwing up my metabolism and messing me up big time. Mm.
Sorry to hear that, but we appreciate you logging in and saying hi to everybody.
Yeah, well, I'm glad to do that. Glad to see it. Good to see you. I was hoping you'd be there. You're about the only one I really want to see. You've been doing well, lad.
Well, how about I reach out to you sometime later on in a few weeks or something, and maybe we can catch up.
Okay, sure enough.
That
So
sounds-
you're still at UF and everything's going well, eh?
Yeah, I'm still at UF. And
You're not getting screwed like Bill Pine did.
no, not yet, but Bill, Bill. He put
Yeah.
himself in positions.
Yeah, yeah.
but,
Yeah, I guess in that state, you gotta be more careful, don't you?
well, good to see you, Carl. I'm gonna catch up with you later on when I'm back home, and we can chat about a few things, what I have going on.
Okay, take care of yourself.
You too.
Hmm. I didn't.
Yes?
Yeah, this was, they wanted me to do this a half an hour before my presentation. They wanted me to do this Zoom test to make sure the Zoom went, I could share the screen in Zoom.
Yeah, and you just did that, so it works well.
Hey, Carl. Can you hear me? Oh, okay, maybe I need to.
Yes.
Yeah. Carl, can you hear me?
Because if he's not wearing his
Okay.
headset, probably he's
Yeah,
not
okay.
listening. So
Before Sheila, Before Sheila starts talking, let me just mention the discussion we had about the next version is just starting. On Saturday at the consortium meeting, there'll be much more about it.
Bring the bell into the microphone.
Okay, I know everybody is still excited to speak to each other, which quite surprises me. But Billy just said, that this is just the start of that conversation, and at the consortium meeting there will be a lot more discussion about it. So now I think Carl is already online, which is very nice. But Carl, we're going to have the presentation of the best student and poster and talk presentations first. So Billy, it's up to you.
Is it? I think it's Kim.
Kim and Billy. Kim is in charge.
It's slide for each winner.
Yes.
Yeah, so.
Right. All right, so the moment of truth is here, I guess. So thank you all for voting, and you all really, stepped up. So we had enough votes. We took some time to look at it, which wasn't that necessary, even though there was a lot of diversity of voting. Both the poster and the oral presentation winner came up really clear from the results. So I think going to the next slide will reveal perhaps that first winner, which is poster presentation, Noah Motz. Come on up.
And while Carl Walters is online and can hear us here, you come over here especially, I'm very happy to give you a copy of our textbook.
Thank you.
Yes.
Really appreciate it. Thank you.
Thank you. Congratulations.
Thank you.
And congratulations. Oh, you need
Over to the side.
One more thing. Wonderful. Okay, thank you.
Next is best oral presentation, and that is Megan Effort. Come on up.
You would have gotten it anyway, but congratulations. At least you get a title out of it now.
Step over there for the picture. Congratulations. Thank you for the presentation, prizes. So like everybody had a great presentation. Good job. The world. Yeah.
Carl, that took quicker than we expected, so or less time than we expected. So yeah, can you come back, please? It's like I'm waiting to.
Carl is gone for coffee.
It's like I can see you here.
Carl, can you hear us? Oh, he's on a phone call.
No.
No?
Yeah, yeah.
So
Go ahead.
yeah.
Okay.
I think we're ready for you, Carl.
Oh, yeah.
Yeah.
You can
Just
hear
give
me
us-
okay?
Yes, indeed. If you give us a moment, we'll put you on the screen and everybody can see you.
Okay. And then I'll be sharing the screen shortly.
Yeah. There we go. Say hello to Carl.
Hey, everybody. Billy asked me to provide some kind of uplifting summary thing for particularly young people. who are getting involved in the development of Ecopath ecosim models and so on with EWE and so on. And I said to him, wait a minute, hold on, Billy. You don't want me to give a talk like that. Well, what I would say to him is run while you can, get it. Don't even think about getting involved in this sort of thing. So he said, no, well, give us some kind of personal view about good practices in the use of EWE. And he and I have really different views about that. So I'm going to show you, just take a few minutes to show you what my main view is. I have to warn you that I'm not feeling particularly well, and I won't be able to stay online for a long time. So I'll make the presentation and then take sort of short questions afterward if you want. And then I need to get on with taking some medications and taking care of my wife who just had surgery. So I will start the presentation here if I can. So now, can you let me know whether you are seeing my screen?
Yep. We need to in full presentation mode.
Okay, did it not go into presentation mode?
Yeah, you have to switch screen.
Oh, there we go.
Oh, yeah.
I'm clicking the wrong button. This is what happens when you're almost 80 years old. Things like buttons on screens when your eyes can't see the screen in the first place don't work too awful well. So Sheila came up with this title for my talk, and I guess that's as good as any. So let me just jump right in here. I just want to make a few simple points. Here's my main thoughts about using EWE for people who are just getting started with it is, first, always start out when you're going to build an EWE model, don't just do it to copy what somebody else did in their representation of an ecosystem, but always start by thinking about the main policy issues that you want to make predictions about. In models for the sake of models aren't interesting. Models that are interesting to people are those that try to make statements about alternative policies that might be adopted in the future. That is, they're models for management or the useful ones. And if you're not interested in policies, if you're interested just in basic questions like how ecosystems are coupled together through trophic interactions and so on, at least think very carefully about whether you're going to learn much about that by building any kind of model in the first place, unless you're just seriously masochistic. Because what we really need in terms of understanding how ecosystems are coupling works in ecosystems is not more models. It's actually more large-scale field experiments that will uncover the importance or not of trophic linkages predicted to be important by models. A third thing is, I'll show you what I mean by this in a minute, is over the years, whenever I've been involved in developing models for any kind of policy problems, I always use what we started calling in the adaptive management world back in the early 1970s, what we call a working outward approach to decide on the main biomass groups or main variables you're going to use in the model. First include those that matter directly to policy, and then add additional variables that you think are necessary to predict the behavior of the variables that do matter to policy. This is different from saying I'm going to take a whole ecosystem and I'm going to partition it up into biomass components. Most often the working outward approach results in a model that is incomplete. In a sense, it doesn't have all of the biomasses represented or represents some of them in only a very aggregated way. Then the next thing I want to talk about a little bit is watching out for vampires in the basement. And I'll tell you what I mean by that in a minute. And then my final recommendation here, and I won't repeat this, is don't ever just build one model. But whenever you're engaged in an exercise that may be of importance to deciding things like ecosystem management policies, build lots of models. Plan on building a whole bunch of them of increasing complexity so you can try to work out where the best compromise is between dealing with policy questions versus getting all kinds of errors and trying to model too many things at the same time. Looking outward starts something like this. I sit down when I'm building a model, I first say, what am I concerned with? Well, for a simple example would be, I'm concerned with the yield of cod from an ecosystem. I said, what do I need to predict? What do I need, variables do I need to predict the cod yield? Well, I need the cod stock. And in order to model a cod stock, I need to model at least some of the prey dynamics that support the cod stock. And I probably will need to model cod predator dynamics over time, although that's often left out of simple models. Predation mortality, or M, the natural mortality rate, is often treated as constant over time in the simpler models. But I would. And then I also need to make predictions in order to predict cod yield about changes in fishing effort that are uncontrolled and other target species and so on and so on. Okay, so the idea is that I start out with a central policy issue, and then I add no more variables than I think are necessary to make predictions about that. And then I try that model out and see how well it works. Well, but when you end this looking outward process, no matter how many additional variables you add, your model will always have a boundary. That is, there'll be variables that are changing in the real world out there that you chose to ignore. And what choosing to ignore really means in an ecosystem model is that you treat those things outside the boundaries of the system not as not being there, but as having constant effects going into the future. And when we see really serious model failures in of any kind of models we use in applied ecology, we find most often the model failures come from variables that we didn't think about. Those are the vampires, or variables that we thought about but didn't think they'd be changing enough to make a big difference over time. One of the ones that's turning up to be important in some ecosystems, as an example, are large whales that are building up in abundances and are having perhaps pretty profound impacts on lower trophic levels, much larger impacts than anybody used to think that they would have as they recover over the years. Okay, so that those vampires, the variables that you don't think about when you start your modeling exercise, just remember that when your model fails, the reason it fails is most likely not going to be because you didn't put enough detail in the model, enough variables in the model. It's because it's going to come from some variable you didn't think to put in there at all in the first place. That's the one that's going to burn you. The other thing is that when you add a model, when you build a model, make it more complicated, you can fit data better and better with the model, but the uncertainty about the effect of each of the variables in the model goes up and up and up. Statistically, there's a matrix that becomes ill-conditioned. And the variance of your ability to explain the policy variables, kind of the product of this better fit combined with more and more errors in components of the fit. And that leads to there being an optimum model complexity. And the only way you can find this optimum complexity is to do the first thing that I recommended to you, which is to build a whole bunch of models, starting out simple and becoming more complex, and try to feel your way to where you're hitting predictions that just aren't reliable anymore. So now let me just close. So now you're an ecosystem model. All I can say about that is good luck. And one last question here, just to emphasize to you that this isn't a simple issue, is how do you know you have the best model? Given that every model you can think of will eventually fail, because eventually there will be a vampire that will come along out there in the world that nobody thought of, that will cause unpredicted changes and so on. Well, why have a simple enough answer to this is that there is no such thing as a best model. You'll never stop making mistakes. The best you can do is not keep making the same mistakes over and over again. And maybe you make mistakes less often. What this is saying is that what you need to be a useful and successful EWE modeler is to learn to be adaptive rather than arrogant in your perceptions of what you need to be doing and so on. So that's basically all I want to say by way of general introduction. So I'm going to stop at that point and let's have a little discussion about the points that I've raised with you. I think they've all been raised in other presentations. They're certainly raised in Billy and I's textbook that I see got given away several copies of. I'm glad to see. So let's discuss the little points that I've raised. Hope I wasn't too nasty with this, but
No. You were not nasty enough. I expected more of you.
oh,
Sorry, I was saying you were not nasty enough. I expected more of you. Questions?
No. I'm getting too old to be really nasty.
Questions, comments? Christy. Hey, Carl, it's Christy Lewis. How you doing?
Hey,
Good to
Christy,
see you.
Good to see you, Les.
Yeah. So I want to ask you a big picture question, just and feel free to answer it however you want. What do you think is the biggest challenge right now to all of us who are building ecosystem models for management purposes?
Oh, that's simple. It's the issue of optimum complexity. It's the issue of how much can you leave out of the models and still have them work properly. It's what I see going on when people are building these monster models where they're trying to couple couple the dynamics across all possible scales. So they're trying to couple hydrodynamic models with NPZ type lower trophic level interactions and then going up through fisheries and to people and to everything. Is that those have a really high failure probability. The thing about these giant models is that it's not like if you get most of the parts right, the machine will still work. The model will still work. The way they behave is if you get any part wrong, the whole thing breaks down. The whole thing falls apart on you. So it's how to deal with this compulsion that most scientists and biologists in particular have of trying to model everything in the world. That's the biggest issue, is how to get away from that and how to make decisions about what model complexities and what models are really useful to particular policy questions. And I think that is particularly important in relation to the single biggest question that you get that you've had raised to you is, what's your crystal ball say about climate change in the future? Where the honest answer to that question, when they're asking you to use EWE as a climate change prediction crystal ball, is it ain't going to work. That you honestly don't have a clue. We really don't have a clue what's going to happen. All we know is that we're likely at climate tipping points, but we don't know which way they're going to tip. So that the best advice you can give is not to even try to make a good prediction. Try to figure out how to be capable of adapting whatever actually that climate change outcome turns out to be. So you should be teaching adaptation, not teaching crystal ball forecasting.
Thanks, Carl. Other questions?
Thank you, Christy, because that reminded me of things I thought I was going to say in the talk and I forgot.
It's as if you guys have spoken to each other before.
No.
Other questions, other comments? Dave, you might want to just say who you are, because I don't think he can see you necessarily.
I
Maybe
can see you.
Hannah.
It's Chagaris again. Hi,
Yeah.
Dave.
Hey, Carl. Great to see you. this question is maybe a little bit self-serving, but most of what we talked about this week are, ecosystem modeling and how we can model ecosystems. But I want to hear like your thoughts on how these models can help improve single species assessments and single species management going into the future.
Well, I think the simple answer to that is that more and more we are getting enough data about single species dynamics from age structure sampling and survey programs to understand that the classic assumption in those models is that the variability is all in recruitment, and that our big single species problem is explaining recruitment. What those models are telling us is that that's not true. That very often recruitment is certainly variable and unpredictable to some degree because of the small organisms, small changes in mortality generate large changes in numbers. But what they're finding in these assessments where they can look at natural mortality rates is that a lot of species are showing really large changes in natural mortality rates, much larger than we had expected. And those natural mortality rate changes appear generally to be associated with trophic interaction changes, changes particularly in predation regimes over time. And that at least some of the apparent response to climate change, for example, in range distribution, expansion and contractions, what's really going on there is not physiological responses to warming. What it is changes in predator distributions and predator abundances that are actually driving some of the range shifts that we see. For example, salmon, coho salmon have gone extinct over the southern part of the range in the Pacific Ocean. That's not because they can't live in the warmer ocean. They're perfectly capable of living there, but they can't live there with the very high predation risk that they face now from a huge California sea lion population that's expanded dramatically over the last 40 years. Their marine survival rates have just dropped to nothing. So yeah, the trophic interactions are turning out in the single species setting. And things like the mortalities that you've tried to model with red tides and so on are turning out to be much more important than the single species assessment people have been willing to estimate to admit until very recently. So now you see a lot of these people flogging the idea of what mice models, simple models that try to target particular variables that are thought to be causing the changes in natural mortality rates as well as in recruitment rates, particularly because of the possibility that some of those mortality agents, ecological ones like predators, are controllable, are manageable, and that we ought to start including the management of them as part of the whole business of ecosystem management. Got to go out there and shoot seals if you want to do good ecosystem management.
There he is. There he is.
It was only a matter of time for that to come out, Carl. I'm not surprised.
Yep.
Okay,
No,
other questions? I have one actually. And I don't know how much you can't see me, but I'm behind the camera, but it's more important that you see everybody else. I don't know if you know that much about what's going on in Europe, but one of the big drivers here is the European digital twin of the ocean. And I mean, there's a ocean decade program like that too. And from what you said earlier about, these models being coupled, not being very useful, I was kind of wondering what you think of that. Do you think it's actually a fool's job?
As I understand what that's doing is it's trying to study whole marine ecosystems in detail. Fair enough, and build whole marine ecosystem models in some detail. What I would view that as being useful is that it is really a way of searching for the vampires in the basement, to try to bring them inside the boundaries of the model predictions. And as long as that's understood right from the start, that it's science aimed at pushing the boundaries of these models, then it's just fine. But you should not be pretending that the models are going to cover all bases and find all vampires the first time around or at all over the next decade.
Yeah.
Is that a fair answer to your question, or is it
Yeah.
answering it at all?
Well, I mean, it is probably the answer I thought of when I heard about it, but it's not the way they're going about it in Europe. They're basically starting by connecting hydrodynamic models with biogeochemistry models. And if you're lucky, that has a fish in it. And then they're calling it a digital twin of the ocean, and they want to actually help use it for policymaking. So yes, I mean.
Well, those kind of models will answer certain kinds of policy questions about certain kinds of issues like eutrophication, changes in freshwater inflows, and their impact on conditions of life for a variety of organisms that depend on estuaries, for example. So yeah, it isn't that those models aren't useful. It's that they're not where a lot of the vampires are.
Yeah, yeah, I agree. I think Jeroen?
Carl, if I can, hi, this is Jeroen. Good to see you again. If I can add to that, the digital twins, what sets them apart from models is that they're fed by near real-time data to integrate and to feed back to managers to timely intervene in the real world. That's what the digital twins are made for. So they're set up for real practical purposes. That's the idea behind these monsters. They're being used in engineering a lot to monitor processes, and they want to apply that now to ocean sciences.
I don't know. I guess I'd have to say to you, I've never thought of it. That's called, I believe, model reference adaptive control. This is the old term for it. And we just don't have, in my experience, there isn't much practical experience out there to know whether or not that approach is going to be that helpful. So it's worth a try as a giant experiment in learning how to be adaptive. But I don't think that anyone should flog it as guaranteed to work at all, compared to some of the classic approaches to making predictions about components that we're concerned with, like fisheries.
Yeah. Thanks, Howard.
So yeah, don't forget, you need lots of models, not just one model.
Yeah, indeed.
Hey, Carl, this is Howard Townsend with NOAA.
Hey, Howard, I haven't seen you
been
for
a while.
Last time I saw you, we were sitting in a restaurant on the banks of the Chesapeake.
Yeah, and I had hair then too. But I was just thinking about, this difficulty we have sometimes with getting managers to, accept advice, and you've alluded to that they're starting to realize with some climate change and that sort of thing, they are starting to pick this up into like single species advice. But that often happens after the collapse, after the warm blob, after we've lost the Bering Sea crab. Do you have suggestions for how to use these to help managers become more proactive, or is that just?
Well, no, I mean, what you're really saying, Howard, is that you're really confirming what I warned you about, is that there be vampires out there. And you just identified a couple of the nastier recent examples of those, like the worm blob that hit everybody by surprise, hit the climatologists by surprise as well. I guess it just the lesson from those things is that there be vampires, and your system must be capable. You must be helping to try to design systems that are capable of dealing with those more and more of those things. And there will be more and more of them. There are more and more things that are becoming unpredictable out there in the world as we approach climate tipping points and the variance of everything goes up and so on.
All right, thanks a lot.
Kim?
Hi,
Hey,
Carl.
Kim.
This is
Yeah,
Kim.
good.
Doing
Kim.
good. I think a lot of what we're working towards is that what we work on our output, that it's used in some way by practitioners and decision makers. And I was wondering, what do you think in your work was maybe a good example or a great project where some output of yours has been used by practitioners, and also what was kind of that key to success that they were like, oh, this is useful. I'm going to now do something different than what I was doing before.
Oh, Kim, that's a nasty question.
Maybe
You
she
know,
should have
to
asked
be
whether there was
completely
one.
honest with you, I can't think of a single example in my work over the years on using models in adaptive policy design. I can't think of a single example of where the models and the adaptive management recommendations that came from uncertainties identified by those models were really used very effectively. There's been a horrific history of failure of the models to be useful for adaptive management, I'm afraid.
Okay.
Can I follow on from that, Carl? Sheila here. Do you
Yeah.
think if you started the modeling by working with the policymakers or whoever you were doing it for, more, if you worked with them more in the beginning to try and precisely know what they actually want, not what they just say they want, that might have helped?
Yeah, absolutely. This is what the whole concept of adaptive management, how it developed. The notion was it developed out of a workshop approach that Buzz Halling and I developed, and Ray Hilborn, where the idea was to bring together policymakers, scientists, stakeholders of various kinds in a room and try to hash through what their real concerns were and what their real options were, what the real actions that they were capable of taking were. And that actually led to a number of successes, but none of them in large systems managed by bureaucracies. I think the two biggest successes I was ever involved in doing that. The first one was in a little alpine village in Austria called Obergurgel, where we had a big workshop with lots of Austrian scientists and bureaucrats concerned with managing the future of the alpine environments of Austria. But there were also hotel owners from the village of Obergurgel. And we ended up building our model around the concerns and knowledge of those local people, their policy concerns. And they ended up using a very simple model that we developed and put on a desktop calculator, or one of these things with the strips. They used it in their Obergurgel town meetings to help plan what they could provide in the way of land for hotel developments, and what young people from the town would have to be encouraged to leave because the hotel developments couldn't be allowed to take up all of the space in the Alpine Valley. So that was one. The other one was with lap reindeer herders, where we were in Sweden. Again, a room full of bureaucrats and academic scientists from Sweden, and a couple of lap reindeer herders. And I ended up spending all of my time talking to the reindeer herders. They had a much better system sense of what was going on, and certainly a much clearer perception of the important policy issues for management of forests in northern Sweden and for the future of the Lap people, which was what this workshop was supposed to be about. They had a much clearer perception than the government people. The government people wanted to just make great big plans, and the Laps wanted to know what the impact might be of specific actions that they could take out there to reduce their dependence on external sources of food for their reindeer in particular. So, yeah, that's a long-winded answer to a simple question.
Carl, what about the camp cooks?
Oh, yeah. There's another example. That's for an example where the details do matter. Where the vampires turned out to be inside the system. We were building a model of the James Bay development in eastern Canada, James Bay hydroelectric development. And there was one of these characters who in the early days of systems analysis used to be called the list makers, who would insist on listing every possible thing that you could include in a model. And this one character from the James Bay Corporation kept saying, well, you have to include the camp cooks. And we kept ignoring him because who in the hell cares about construction crew camp cooks in a very large hydroelectric development? There's so many huge environmental changes taking place with the hydro development that the camp cooks are trivial. But what it turned out happened when we finally, just to make our model, just to shut him up, we said, okay, we'll put the camp cooks in the model. What's your concern? So he showed a little simple calculation that showed that the camp cooks would actually have a larger impact on the fish in the region, like lake trout and other northern sensitive fish species, than all of the hydro developments would. The reason being that these camp cooks don't have much to do during the day, and what they do is they fish to provide fresh fish for the construction camps. And they catch a huge number of fish, a lot more than the number of fish actually impacted by the hydro development itself. So there's an example of where the vampire was a detail that we didn't think about within the system, where we treated as constant or small, and it just wouldn't matter, but it did in the end.
That's a great example, Kat.
Yeah.
Okay, other questions, comments? Are we going to let Carl go and rest because it's really early for him? Have a coffee or something?
Oh, thank you. Thank you, guys. Thank you for having me. And
Thank you very much for coming.
My very best to all of you, and good
Yeah.
luck in your careers and everything else. Take care. We'll see
Thanks,
you in a couple
Carl.
of days, Billy. Yeah.
Thanks.
Bye-bye.
All right. I think, if I'm not mistaken, that's it for us. Is there more to say? There's a closing. And I'm assuming, Willie, you want to say something in the closing?
Classic.
Okay, other than that, hold on. But did you want me to be there?
I wanted to say something.
Both up there.
See, you even mentioned first.
All right. So, yes, I think from my side, just thank you all for coming. It was great. I've learned a lot. I've remembered a lot that I had forgotten. So that's wonderful. And a reminder again that tomorrow morning at 8 o'clock, the workshops start, except for the data lakes, which starts at 9. So please be here. And if you want to still come to the workshops, come. We'll invoice you later. I think that's the bottom line. And is there anything else? And the people who are training, who are doing the trainers, I want you here when Willie has stopped speaking. Thanks. Oh, yes. And you can take your posters. Please take your posters because we will take them down now. It'd be nice if you go and take them down yourself because we're closing off the poster boards and we will be rearranging this because tomorrow morning we have the workshops in here in a kind of a U style so we can actually see each other. So yeah, it was really lovely. And please help yourself to extra goodies because otherwise he's going to have to take it home with him on the plane. And apparently we just got 2 boxes of more bags. So if you want more bags, please take them.
Oh, absolutely. Absolutely. They're great. So something and something more. No, yes. I think it has been a real great conference, and it absolutely in the succession of birthdays, it absolutely has a great space. And that's thanks to you and your contributions. It has been really neat. It's been a pleasure to see how well things have worked out. At least it's partly due to you and your contribution, because the other really important part is the European Marine Board. Oh, yeah, but for the facilities, absolutely, yeah. It reads even that far that the American in the corner thought, let's come back in 5 years because everything has been so perfectly well arranged here. So that's an interesting suggestion. No, but it really has. And I believe that Sheila has this little beer bell, which basically means let's close this conference. Thank you all.